Subject
Okay. Yeah. Hello. Hi, dear students. Can you able to hear me? Hello. Can you able to hear me? Okay. Right. Yeah. So I hope fine. Yeah. Good evening to everyone. Hello. Yeah. Good evening. Good evening. Welcome to the session. Yeah. Fine. Fine. The students are still keep on joining. Already we are 5 minutes late. Okay. Yeah. So in the last class, we are completed that the synchronous motors, synchronous generators, and synchronous motor connected on the infinite bus bar. And we have seen the, just a minute. Okay. Yeah. It's okay. Fine. Fine. Yeah. See that synchronous motors, the effect of change in excitation, we have seen under no load condition, we are completed. But no load condition on synchronous motor, effect of change in excitation, what we have observed. So for over excitation, it is ZPF lagging. Under excitation, it is ZPF leading. For over excitation, it is ZPF lagging. Under excitation, it is ZPF, sorry. Over excitation, ZPF leading. Under excitation, it is ZPF lagging. So over excited synchronous motor behaves as a capacitor, and under excited synchronous motor operate as an inductor. Even generator also same thing. Now I have compared. Over excited synchronous machine, both generator and motors act as capacitor. Under excited synchronous motor will behave as inductor. Fine. Yeah. Now in this class, let us see the effect of change in excitation under load condition. Load condition. Let me share this. Okay. Yeah. So effect of change in excitation. Effect of change in excitation. Effect of change in excitation under load condition. Load condition, mechanical power input will be kept constant. Yesterday we have seen no load condition. No load condition power factor is 0 leading, 0 lagging. As I told very beginning, under no load condition, the power factors of AC machines are 0. But now let us see effect of change in excitation. Mechanical load is kept constant. Mechanical load is kept constant. Mechanical load is kept constant. So load condition. This is load conditions. Under load condition. So synchronous motor connected to the bus bar. Okay. Mechanical load is kept constant on this mechanical load. This is a mechanical load. So we are discussing under load conditions. Right? Are you ready? Still people are keep on joining. No. So if you come and join in late, link will miss, na? Right. Okay, anyhow, now let us start. Effect of change in excitation, mechanical load is kept constant. Mechanical load is kept constant. And when mechanical load is, it is kept constant. Mechanical load is kept constant. When mechanical load is constant, what happened? Mechanical power output constant. Mechanical power output is constant. P mechanical is constant. P mechanical is constant. When P mechanical is constant means, what about P electrical? P electrical also constant, na? Yes. Power input is constant. Power input is constant. But we are changing the excitation. We are changing the excitation. Field current we are changing. When field current changes, E will changes, na? Yes. E changes. V terminal voltage is constant. Terminal voltage is constant. Okay. Yes. So when each IF changes, E will be changes. When E changes, definitely Q will change. Correct? Q will change. Q may be delivered or Q may be absorbed, but Q also will change. Q will change. So from this, yeah, mechanical power constant. Mechanical power is constant. So power is equal to EV by XES sin delta. Power is equal to EV by XES sin delta. RA neglected. Power is equal to EV by XES sin delta. And that is also equal to V into IA cos phi. V into IA cos phi, that is constant. Constant. Why? Why? Because mechanical load is constant. Mechanical load is constant. Therefore, power is constant. But anyhow, V and XS is constant. Na? V and XS are constant. V and XS are constant. Then power is proportional to E sin delta. Power is proportional to E sin delta. And that E sin delta must be constant. E sin delta must be constant. Correct? Yes. E sin delta must be constant. Why? Because power is constant. Power is constant. E sin delta constant. Similarly, power also proportional to IA cos phi. Power also proportional to IA cos phi. Therefore, IA cos phi also must be constant. IA cos phi also must be constant. Right? These are the important things. IA cos phi constant. Why constant? Because of this relation. Do you remember this relation? So, these will be, yeah. So, this is E sin delta. From this relation, you can correlate. You can correlate. Here, can you able to listen? Yeah. Power is equal to EV by XS sin delta means Vx is already constant, then power is proportional to E sin delta. Therefore, E sin delta also must be constant. Na? Yes, E sin delta constant. So then only the total whole thing is constant. And here Vi cos phi also constant. V anyhow constant. Ia cos phi must be constant. Ia cos phi must be constant. Right? Yeah. Similarly, other relations. E is equal to V is equal to E plus J into IAXES. V is equal to E plus J into IAXES. And Q is equal to V by XES. V by XES. V minus E cos delta. V minus E cos delta. Okay. Yes. Now, by seeing all the things, are you getting any flashback for you? Any flashback for you? We have seen similar topic in the case of a synchronous generator. Same topic we have seen. That's the reason I am writing same wording. Only the difference is in synchronous generator, what I have given, effect of change in excitation, their mechanical power input is kept constant. Mechanical power input to the shaft we are connected mechanical power input na, yes. But here it is mechanical load is constant. When excitation changes, the same steps are same. Correct? E sin delta constant, Ia cos phi constant. This topic is related to which topic? Tell me. There are two topics. An infinite bus bar in our synchronous machine. It may be generator or motor. Only two topics. One is effect of change in excitation, mechanical load constant. For that, so one topic is related to V curves and inverted V curves, and another one is related to locus of E is a circle. So this related to which topic? V and inverted V curves. Correct? This is related to Ia cos phi constant. When Ia cos phi constant means Ia increases, power factor should reduce. Power factor will reduce. Right? So this topic is related to V curves and inverted V curves. This topic is related to V curves and inverted V curves. V curves and inverted V curves. I don't want to draw the phasor diagram. Phasor diagram you can refer in the material. We have seen already generator. Only generator E should leads. Motor E should lags. Same story. Phasor diagram I have given in the material, you can refer. For gate examination, those who are preparing, not necessary to refer also. I will give the conclusion straight away. Okay. So this is Ia cos phi constant means then you have to realize that it must be related to V curves and inverted V curves. Okay. That is Ia cos phi constant. And E sin delta constant means as E increases, sin delta will be reduced. So no phasor diagram is required. See. Yeah. This topic is related to, once again I am writing. This topic is related to V curve and inverted V curve. V curve and inverted V curves. Same headings. For same topic we have seen. We have seen in alternator. Okay. For the phasor diagram, only the difference is, I have shown also one phasor diagram, generator and motor. Only difference is in generator, E leads V. E leads the V. But in motor, E lags the V. Okay. Yeah. So refer the phasor diagram. Phasor diagram in material. Okay. We have given material na? Yes. In the material you can refer. So I don't want to draw because it is waste of time. I am not discussing any other batches also. Not required. Why unnecessary? Heading is important. Now let me draw the V curves and inverted V curves. V and inverted V curves of synchronous motor. V and inverted V curves of synchronous motor. This is IA and power factor. IA and power factor. This is excitation. Field current excitation. Excitation. Okay. Now, V curves and inverted V curves. This is V curve. Inverted V curve. For normal excitation, this is for normal excitation. This is for under excitation. This is for over excitation. Over excitation. Similarly, you can also draw variation of delta also. Variation of delta also. Delta with respect to excitation, IF. Excitation. With respect to excitation. Okay. Yeah. And already we have seen for motor under excitation, which power factor? For motor under excitation, power factor is lagging. Lagging power factor, correct? Yes. Over excitation, leading power factor. Over excitation, leading power factor. Under excitation, lagging power factor. UPF. Okay. Yes. And under excitation, Q absorb. Q absorb. Under excitation, Q deliver for over excitation. Normal excitation, Q is equal to 0. Normal excitation, Q is equal to 0. Okay. And variation of delta is like this. Delta. Okay. So for under excitation, motor lagging power factor. Over excitation, leading power factor. What about generator? Tell me. Generator for same diagram we have seen. Yes, same diagram we have seen. But only difference is for under excitation, their alternator is leading power factor. Under excitation, leading, over excitation, lagging power factor. That is only difference. Rest of the things are same. Everything is same. Okay. Yeah. So all these things you will get from the phasor diagram. No phasor diagram is required. You can easily remember this one. But very important thing is left for you. Dear students, you have to say this point. Which is V curve, which is inverted V curve. That is ultimately you have to say. Rest of the things you can remember. But which is V curve, which is inverted V curve? Tell me, this V curve is current up or factor? Is the V curve is current or power factor? Inverted V curve, tell me, inverted V curve, power factor or current up? Inverted V curve is power factor. This is armature current IA. Correct? Do you remember? I have given one statement in the last class. What is that? During this discussion, what is that? For normal excitation, power factor is UPF. In synchronous machine, entire thing. For normal excitation, power factor is UPF. Important point is, for normal excitation, power factor is UPF. UPF. That is maximum. Power factor is maximum for UPF only, na? How much power factor? Maximum will be only 1. Maximum is 1. Maximum is 1. Okay. If you remember this point enough, na? Yes. If normal excitation, where it would be middle, at the middle. So for normal excitation, power factor is maximum at the UPF. So power factor curve, it is maximum at the middle, and on both sides it is reduces. Na? Both sides it is reduces. That's what inverted V curve. That point is enough. Okay. Yeah. So these are the delta variations. Just have the idea about all these things. So these points are important. Now coming to the questions Also, we have discussed in alternator, na? Same kind of questions. Same kind of questions it can be asked. So let me give one question so that you can identify. You can correlate with whatever we have discussed in synchronous generator also. Let me give one question. The question is, an alternator, not alternator, synchronous motor. A synchronous motor is operating on the bus bar. Operating on the bus bar. Synchronous motor is operating in the bus bar at leading power factor. At leading power factor with constant mechanical load. Constant mechanical load or constant power output. Or constant power output. Constant power. Okay, constant power with constant load, mechanical load. If the excitation increases, then power factor dash, IA dash, delta dash, Q dash, P dash, E dash, V dash, F dash, N dash, TEM dash. TEM dash. Okay. Synchronous motor operating in the bus bar at leading power factor with constant mechanical load. Constant mechanical load. If the excitation increases. So that is, you should remember always this V-curves and inverted V-curves. Given na? Yes. Is IA and power factor. So one is V-curve, inverted V-curve. IA and power factor. Okay. The delta. So we know that this is lagging power factor, leading power factor. So you are at which power factor? Leading power factor. So when you are at leading power factor, as excitation increases, what is happening? Power factor is decreasing. Power factor is decreasing, current increases. Power factor decreases, IA increases. Okay. What about delta? Delta will decrease. Delta decreases. Q will be delivering. Delivering will be increases because Q always inversely proportional to power factor. Once you know the power factor is decided, Q will be reverse. Q deliver increases. What about P? P is constant, no? P is constant. P constant. E is increasing. Excitation increases, E increases. V, terminal voltage is constant. Of course, it is a supply voltage, it is constant. Supply frequency will be constant. N, this is important thing. When field current changes, will be there any change in speed? No change. I have given speed cannot be controlled by changing the excitation. Field current changes, speed is not going to be changed. When speed changes, if you supply frequency change, then only speed will changes. So speed always constant only. As long as frequency constant, speed constant. TEM, the TEM will be TEM also constant. Right? Yes. Okay. Fine. So this kind of questions, I hope. Remaining questions also you can expect how they are going to be. Even if I give the same kind of the things, na? So from the phasor, from this V and inverted V curves, we can able to answer. Okay. So we have discussed so many questions for synchronous generator. Same questions you can, wherever generator is there, simply you replace with motor and you can give the answers. Right? Yeah. So only difference is power factor for generator, leading power factor, lagging becomes leading, leading becomes lagging. V curves, inverted V curves, both are same, na? Yes. You draw side by side and you check it. What is the difference? Only power factor is different. Lagging becomes leading. So under excitation, generator leading, but motor lagging. Okay. Now coming to the next topic. Effect of change in mechanical load. There are two changes are possible. Excitation is in our hand and load also in our hand. Load can be increased, load can be decreased. Those only changes possible. Generator mechanical power input we have changed, but here mechanical load let us change. So next topic is effect of change in case 2. Load condition, effect of change in mechanical load, effect of change in mechanical load. Excitation is kept constant. Excitation is kept constant. Excitation is kept constant. Sorry. Excitation is kept constant, load we are going to change. Okay, V always constant, but we are changing mechanical load. Mechanical load is connected. That mechanical load. IF is kept constant. Mechanical load we are changing. Excitation is kept constant. The field current is kept constant. Field current is constant. When field current constant means E also constant. E constant. And we are changing the mechanical load. P mechanical is changed. When P mechanical load is changed, it means P mechanical also will changes, na? Yes, P mechanical also will changes. P mechanical will change. When P mechanical changes, then P electrical also will change. P electrical power will change, na? Yes, definitely. It will draw more power. As load increases, say mechanical load increases, ultimately load want power, it will draw from the bus bar. It will draw from the bus bar. P increases. Right? P will increase. Yeah. Now, what about Q? Q also will change because delta is going to be changed. Delta changes means Q not only depends on excitation, dear students. Remember, Q is depends on the delta also because Q is equal to V by XCS, E cos delta minus V for alternator. Motor it is V minus E cos delta. Okay. Q will also changes. That we are going to write all conclusions. So in this, power is equal to EV by XS sin delta. EV by XS sin delta. V and XS, they are constant. V and XS are constant. E also constant. E also constant. Why? Because excitation is constant. Since excitation is constant. Excitation constant. E constant. Then power is proportional to E, V, XS, all these things are constant. Then power is proportional to sin delta. Power is proportional to only sin delta. Power is proportional to sin delta. Okay. Power is proportional to sin delta. Therefore, as mechanical load increases, power increases. As mechanical load increases, power increases. Then sin delta increases, na? Yes. Sin delta also increases. Then delta also will increase. Delta has to increase. As mechanical load increases, P definitely increase. Delta has to increase. Why? Because V, E both are constant. No phase difference. When mechanical load increases, rotor poles lags. Rotor poles will lags. Delta increases. And other relations are well-known relations. What is that? V is equal to E plus J into IAXS. V is equal to E plus J into IAXS. And Q is equal to what? V by XES, V minus E cos delta. V minus E cos delta. V minus E cos delta. So based on this, let me draw the phasor diagram. Here I want to draw the phasor diagram for synchronous motor. Earlier diagram, vehicles, inverted vehicles, not necessary. But for this to get the conclusions, let us draw the phasor diagram. It won't take much time. Already we have drawn for generator. Motor, it is just a mirror image. Okay. See, sin delta, as load increases, this is important thing is load increases, delta increases, E constant. E constant. Yeah. So this is V. This is V. V. And E will be on this side. E will be lagging. E lagging, no? Yes. This is E. This is E. This is V. J into IAXES. J into IAXES. This is J into IAXES means IA will be perpendicular to this. This will be the IA. IA is perpendicular. This is IA. IA. Which direction phasors are rotating? Counterclockwise direction. Phasors are rotation counterclockwise. E lags. E lags. But of course, E may be greater than V also. Dear students, in synchronous motor, E may be more or less or also equal. Only synchronous motor. Except all other motors. If you take a induction motor also, back EMF is less than DC motor, EB always less than V. But synchronous motor, E can be greater than V also. Here I am taking, it is for over excitation, E greater than V. This is delta. This is delta. This is phi. Now, as mechanical load increases, delta has to increase. Delta has to increase means delta will shift like this. Delta shifting is like this. Locus of E is a circle. Locus of E is a circle. Delta will shift like this. Delta, locus of E is a circle. E shifting. There are only two topics you have to mainly focus. One is locus of E circle, one is V curves and inverted V curves. So this is locus of E is a circle. So this is E. Now for various E, different instance if you take, this is E. 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 E shifting, more lagging. As load increases, generator it was this side. Motor is shifting lagging. Generator is going to be more leading. E is more leading, whereas in motor, E is more lagging. Now join E to V, this is drop. J into IA1 XCS, drop. Join V to E, this is J into IA2 XCS, J into IA2 XCS, This is J into IA3 XCS, J into IA3 XCS, J into IA4 XCS, J into IA4 XCS, and J into IA5 XCS, J into IA5 XCS, J into IA6 into XCS, J into IA6 into XCS. Okay? Yeah. So these are the drops. If you join E to V, drop. And remember that direction of IAXS should be always E to V, E to V, E to V. But in generator, V to E, V to E, V to E. Now, let me draw the current vector. Current is always perpendicular to the drop. Current is always perpendicular to the drop. So IA1, see, IA1. This is IA1, yes. IA1, that is perpendicular to IAXS drop. IA1 is perpendicular to IAXS, IA1 XS drop. And IA2 XS will be, this is IA2 XS, na? Yes. If you see, this is IA2 XS. For IA2 XS, this will be the perpendicular. IA2 is perpendicular to that. IA2. That IA2 will be perpendicular to that. Is perpendicular to this. This is perpendicular. Okay, this is perpendicular. IA2. Similarly, IA3 XS horizontal. Therefore, IA3 is vertical. IA3, that is corresponding to what? UPF. IA3. This is IA3. It's IA2. IA3. Now IA4. Similarly, IA4 is perpendicular to this. This is IA4. IA4. And this is IA5 XCS. So this is IA5. IA5. And IA6 XCS. That is perpendicular to this. IA6 XCS. IA6. This is IA6. Right? Okay. IA6. I am drawing simply current perpendicular to the reactance drop. This is delta 1, delta 1. This is delta 1. What is this? This is delta 2, delta 2. And this is delta 3, delta 3. like that. As delta increases, see power factor angle phi 1, phi 2, phi 3. The power factor angles are phi 1, phi 2. For example, this is phi 1. This is phi 1 angle. This is phi 2. Power factor angle phi 2. Phi 3 0. This is phi 4, like that. Phi 4, and this is phi 5. Power factor angle. Now let us do the conclusions. Let me write the conclusions straight away. Conclusions. In this, dear students, okay, observations, we kept a mechanical load is changing. Mechanical load changes, excitation constant. But even excitation constant, power factor is changing. Why? Because power factor also depends on the active power also. Active power changing, na? When load increases, it will draw more active power. When more active power means the power factor is also depends on the active power. So delta changing, power factor is changing, current is changing, reactive power also changing. How all they are changing? Let us write on this. I will divide this into two regions. We will divide that into two regions: lagging power factor region, leading power factor region. This is leading power factor region. This is said to be leading power factor region. Leading power factor region. Leading power factor region. This side, lagging power factor region based on the currents. Lagging power factor region. Lagging power factor region. Okay. And which direction phasors are rotating? Phasor rotation is counterclockwise direction only. Phasor rotation is counterclockwise direction. Phasors are rotating counterclockwise. Phasor rotation is counterclockwise direction. Phasor rotation. Phasors are rotating counterclockwise, then counterclockwise direction. Then only E lagging, no? E should lags. The same diagram we have seen in generator, no? What is that? Mirror image. E, all this diagram will be this side. When load increases, what is happening? E shifting. E is more lagging. E shifting right side. But phasor rotation is counterclockwise direction only. Okay. Just a minute. See here. Can you able to see my pen? Hello. See here. See my pens. This is back EMF. Black color is back EMF. And this is V. We say V. Dear students, listen. V. Okay. At this condition, some angle is there. Some angle is there. This is a delta. Delta say angle between V and E. But these both are rotating in counterclockwise direction. Counterclockwise direction only rotating. Counterclockwise direction. And when load increases, E shift more angle. E shifting right side. But rotation is in counterclockwise direction only. Phasor rotation is counterclockwise. Still, if you increase the load, this is shifting, delta increasing some 40 degrees. Rotation is in counterclockwise direction only. Counterclockwise direction. Still load increases. It is 60 degrees. But phasors are rotating in counterclockwise direction. And if you get 90 degrees, delta 90 degrees, vector rotation is counterclockwise direction only. Okay. Shifting, what I want to say, delta, how it is increased delta, it should be more lagging. Delta 30 degrees, 40 degrees, 60 degrees, 90 degrees. But so phasor rotation is counterclockwise. Fine. So here IA1 and IA2. See, IA1 and IA2, they are said to be leading power factor. IA1, IA2 leading power factor. They leads the voltage. IA4, IA5, IA6, they are lagging. Yeah. Now, let us make the conclusions. See, the conclusions are for leading power factor. Leading power factor as load increases. What is happening power factor? Tell me. What is happening power factor? Even you can see here, IA1 is there. IA1 related to delta. When load increases, delta to increase. Now IA2 coming closer to V. When load increases, E shift like this. IA also coming closer. IA also shifting. Shifting is same. Right? E shifting, then IA also shifting. Now when load increases, IA coming closer to V. This is V na? Yes. Coming closer to V means phi reduced. Phi reduced means power factor increase. Power factor increases. When load increases, power factor will increase. When leading side, power factor is proportional to load because it is coming closer. You have to see shifting. Current shifting na? Yes. IA1, IA2 coming closer. So therefore, I can write power factor is proportional to mechanical load. Power factor is proportional to mechanical load. Load increases, power factor increases this side. Similarly, come to the lagging side. What is going to happen? Lagging side, it is moving. Already current is this side. As load increases, E shifter, IA also shifting right side. Right side is that of the voltage. So therefore, it is going far away. It is going far away. Angle increases, power factor decreases. Load increases, power factor decreases. Inversely proportional. Power factor is inversely proportional to mechanical load. Power factor is inversely proportional to mechanical load. Inversely proportional to mechanical load. Okay? Yes. And then Q automatically, once power factor is decided, Q will be leading means it will be deliver. Q delivering is inversely proportional to mechanical load. Inversely proportional to mechanical load. But whereas Q absorption, lagging power factor absorption is proportional to mechanical load. The power factor inversely proportional, Q will be proportional. Similarly, IA is increasing as load increases, IA increases. Why? Because potential difference is increasing. Potential difference is increases, delta increasing, current increases. So IA proportional to mechanical load. Delta also proportional to mechanical load. Delta proportional to mechanical load. Power also proportional to mechanical load. All they are proportional. Even leading side also, current to delta, all other things are proportional. IA is proportional to mechanical load. IA is proportional to mechanical load. Delta is proportional to mechanical load. Power also proportional to mechanical load. Okay. So very important thing is these are the yes. Okay. Now questions can be based on this, but you need not to by heart these conclusions. Have in your mind the phasor diagram. Which direction is shifting? E shifting which direction? I also will shift both in same direction. Okay. So let me give one question based on this. Yes. See, the question is, have taken na? I hope this is clear. I will come to your doubts. First, let me complete this question. Thing is, A synchronous motor. A synchronous motor operating on the bus bar. Synchronous motor is operating on the bus bar. Operating on the bus bar at lagging power factor. Lagging power factor with constant excitation. With constant excitation. With constant excitation. Okay, yes, constant excitation. Now, if the mechanical load, if the mechanical load increases, then power factor dash, comma IA dash, delta dash, Q dash, P dash, E dash, V dash, F dash, N dash, TEM dash. Okay, the mechanical load increases, then power factor. What happened current? What about delta? What about Q, P? Power factor. Now you can remember the diagram. E will be more lagging, no? Yes. E will be shifted like this. You are which side? Lagging side. Lagging side, and this is V. Current is on this side. Shifting. Okay. So current is E shifting like this. IA is moving. IA is moving means this is V. So IA going far away. Phi increases. Power factor decreases. Power factor decreases. Power factor decreases. What about IA? IA increases. Delta also increases. Q decreases. Q lagging means absorbing. Absorption increases because Q is inversely proportional to power factor. Q is inversely proportional to power factor. P increases because we are increasing the load. Now P increases. E is constant. E excitation is kept constant. Now E constant. What about V? V also constant. F anyhow constant. N also constant. Load increases. Now when load increases, is there any change in speed? No change in speed. Speed extremely constant. No load also synchronous speed. Full load also synchronous speed. TEM, yes, TEM will definitely increase. Electromagnetic torque increase. Electromagnetic torque increase. Load increase, electromagnetic torque increase. Speed constant. Okay. So these type of questions only. The other things we have discussed in the case of synchronous generator, na? Same kind of questions. So, and this diagram also you can remember easily. What you do, you keep these two diagrams side by side and observe it keenly. Shifting only, na? This side say it is coming closer, leading side. Power factor increase. Power factor proportional to mechanical load. What happened in generator? Tell me, generator. Generator, E will be this side. As load increases, E shifted. If current is this side, it is going away from that. The power factor is reduced. As load increases, power factor reduced. Inversely proportional. If you see these conclusions in the case of generator, power factor and Q both are inverse proportional. Power factor is decided, that is enough. Power factor inversely proportional in the case of generator. Okay, but here it is proportional. So just have idea, there matter ends. Only after getting some clarity, these topics will be same. Okay, fine. Yeah. So with this, we are completed synchronous motors, and one important topic is also there. That is for various disturbances we are going to see. First, what I want to do, I would like to do some problems on synchronous motor. Okay. And before that, a small announcement for you people. The timetable in charge, he has given Yeah, I would like to announce that. See, because tomorrow onwards, the new topic they are going to start. Just a minute. Yes. Okay. The announcement for you is announcement is tomorrow. Tomorrow schedule. Tomorrow schedule is 5:30 p.m. to 5:30 p.m. to 9:30 p.m. DC machines. DC machines. And the information is link is already shared for you people, no? Yes. But the link is shared only for online batches. The link will come for whom joined for online classes only. Links will not be provided for offline classes. Link will not be provided for offline classes. Okay. So tomorrow onwards, link not provided. Tomorrow onwards, link not provided for offline batch students. Okay. Link is provided only those who have joined for online classes. Offline batches, no link will be provided. The link is only provided for online batch students. Those who have joined for, link will be provided only for the students. Those who have joined for online batches. Okay. This is what is informed, particularly is mentioning many times. Inform at the beginning. Okay. Right? Right. So I hope you have noted this point. Yeah. Now, let us come to the doubts. On this topic, any doubts are there, you please ask. And then we will shift to the problems first. And after the problems, at the end, I am going to take a small topic. Of course, we have discussed all the things, but when excitation fails, typical questions. Already we have discussed just summarization of all the questions. Instead of questions, I will give the statements. Those statements are also going to be questions. Okay. Yeah. Tell me any doubts. Hello.
Hello, sir.
Yeah, tell me.
Sir, you previously said a point that the tail is increasing when we are load is changing. It may be generator or motor.
Yes.
Okay. Then there is another point you said that for 90 degree when we are going to out of synchronism.
Yes.
After that, then that magnetic locking is with a certain angle. Means for no load, this magnetic locking is something happening. For del barabar 0.
Del for more than 90, yeah?
Means as del is increasing up to 60 degree, 70 degree.
Okay.
Then there is a chance of that pole will be come into picture of another pole. Means so that there is a chance of out of synchronism. Means
no, not 60. Even 60, though it is coming closer to that, mainly North Pole and South Pole is only aligned. That other pole effect, similar pole. I understood. Your point is the poles are similar opposite poles are existing under that. For
Yes.
example, this is North Pole and South Pole, and North Pole and South Pole.
Yes.
Okay. And when load increases, say, the rotor pole lag. Fine. But what is the delta? Delta is not angle between this North Pole and South Pole. I have given delta is the angle between the main field EMF and resultant EMF. FM and FR, angle between stator poles and rotor poles, that is a torque angle. Stator EMF, rotor EMF.
Means,
Even though, okay, you may be interpreting like that. This pole is like this, it is coming
okay.
means only interaction between these two. If
Ah.
more than 90 degrees means mechanical angle, you may be finding mechanical angle there. Mechanical angle, but you have to take every time it is electrical angle. Electrical angle. So if more than 90 degrees means there is a choice of, instead of attraction, repulsion will dominate. Attraction between the similar opposite pole, North Pole, South Pole. For less than 90 degrees, North Pole, South Pole interaction will be there. But as delta increases, locking is reduces. But locking is not going to be fail. If more than 90 degrees, what is going to be happen? It will come to the similar pole will comes under the similar pole. Influence is more. Then there is a choice of repulsion. Instead of attraction, repulsion will comes into picture.
Means,
And that to be, nobody will discuss about delta more than 90 degrees means there is no behavior is exist. It is simply the things will be, the power is going to be reduced means that portion is never be is used actually. Machine is never be analyzed after that also. Delta will be more than 90. But you are correct. When delta more than 90 degrees, electrical angle say, then there is a influence instead of North Pole, South Pole locking, it will comes under the North Pole, come closer to North Pole.
Okay.
Okay. Hello. Next. It's related to this topic. Any doubt? Yeah. Hello. Hello. Okay.
Hello, sir.
Hello. Tell me, Kalyan, quickly.
Sir, good evening, sir.
Good evening.
Sir, tomorrow morning, which subject, sir?
Tomorrow morning, I don't know. This topic he has given. Tomorrow evening schedule he has given. You may be getting, I don't know exactly.
Okay, okay, sir. Thank
He
you.
may be given. He may be given.
Okay, sir. Thank you.
I don't know. Exactly. Tomorrow evening schedule he has sent to me. That is what I am getting.
Yes, sir.
Fine.
Thank you.
Okay. Yeah. Now let us go to the next topic. Problems. Let us see some problems. I want to do some gate problems, not all the gate problems. Already solutions are given and there is no meaning to do all gate problems. Right? For each model, one problem. I have prepared my own problems. Okay. So which has given the material that we are going to see. And also some problems that are given for the gate examination. It is to have the idea about, to have some idea. Right. First, starting with synchronous motor. Synchronous motor. Okay. See, in gate 2014, question is for 2 marks. Question is a 400 volts, a 400 volts, 50 kVA, 0.8 power factor, 0.8 power factor leading, 0.8 power factor leading. Delta connected, comma 50 Hz, synchronous motor, 50 Hz synchronous motor. XS is equal to 2 ohms, RA0. Friction plus windage losses. The losses concept are same. I didn't discuss. Not necessary. Induction motor you have seen, na? Same losses will be here. Mechanical losses, iron losses, copper losses, that is same. Efficiency problems also same. Is equal to 2 kilowatts. And copper core losses. Core losses means iron losses. Is equal to how much? 0.8 kilowatts. 0.8 kilowatts. Shaft is supplying. Shaft is supplying power output. Shaft means power output is 9 kilowatts. 9 kilowatts at 0.8 leading power factor. 0.8 leading power factor. Then IL is, then the line current is IL is dash. IL is dash. Starting with a very simple problem, but simple problems also is important. Na? Yes. Just to have idea, I am saying what kind of questions that can be asked. See how simple the solution is. He has given power output. Then loss is also given. What is power input? Our output is equal to 0.8. Our output is how much? 9 kilowatts. Then what is power input? Power input is equal to power output plus losses. Output losses. That is 9 plus losses is how much? 2 kilowatts friction and windage losses plus 0.8 is 11.8 kilowatts. But power input is equal to what? Root 3 VLIL cos phi. VLIL cos phi. And power input is given how much? 11.8 kilowatts into 10 power 3 is equal to root 3 into VL. VL is equal to 400. The data given is always line voltage. 400 IL, you need to calculate power factor 0.8. So then what is IL? Line current. Line current is equal to, from this you will get 21.29 amperes. This is the type of question. What is there in this question? Nothing is there now? Yes. Okay. Yes. See, next question. Taken. Yeah, this is GATE 2016. GATE 2016 examination. Question is a 3-phase 50 Hz. Remember, dear students, GATE examinations is nothing but problems mainly. Problems practice is very important. Don't neglect the problems. Those who are practicing the problems, right? You are strong in the problems, definitely you can crack the examination. Don't neglect the problems. 50 Hz. Salient pole synchronous motor. Salient pole synchronous motor. XD is equal to 0.8 per unit. 0.8 per unit. XQ is equal to 0.6 per unit. RA is equal to 0. RA 0. Yeah. It is drawing full load current. It is drawing full load current. Full load current at 0.8 power factor leading. 0.8 power factor leading. And V is given 1 per unit. 1 per unit. Then E in per unit is dash. That is a question. Here 2016 examination. If a salient pole synchronous motor is given, XD is given, XQ is given, RA 0. It is drawing full load current at 0.8 power factor leading. Yeah. So it is given per unit values, means no conversions are required. It may be a star connection or delta connection, whatever it may be, no conversions are required. That is advantage of per unit values. No? Directly you can take. Directly we can take. Fine. E you have to find now. Yes, XD is given, XQ is given, drawing full load current at 0.8 leading. E we have to calculate. And we know E is equal to V cos delta minus IQRA. Yesterday I have given relations. Minus R plus IDXD. So you have to calculate what? ID you have to calculate. Okay. Delta you have to calculate first of all. To calculate the delta, what to do? Tan psi is equal to, we know tan psi is equal to V sin phi minus R plus IAXQ divided by V cos phi minus IARA, synchronous motor. Do you remember? Yes. But for leading power factor, what is that? Plus. Plus for leading power factor. Leading power factor is plus. Therefore, I can use plus for leading power factor. So, let me use plus here. Directly I am using plus. Synchronous motor equation yesterday I have given, na? Yes. V sin phi plus IAXQ. What is V? V is equal to 1 per unit. Sin phi, 0.8 leading means this is 0.6. Power factor is cos phi is equal to 0.8 leading is given. Then what is the sin phi? Sin phi is equal to 0.6. 0.6. Therefore, that's the reason I am using 1 into 0.6 plus 1 into XQ, how much? 0.6 divided by V cos phi. 1 into 0.8 minus 1 into 0, RA neglected. Okay. That is equal to, you will get 1.5 finally, ratio 1.5. Fine? Yes. This is plus or minus, na? Minus or plus. Plus for lagging power factor, plus minus for lagging power factor, plus is for leading power factor. Leading power factor and UPF. Remember, this minus or plus I am using plus. Why? Because it is positive. Leading power factor. So psi is equal to how much? Psi. Psi is equal to, you will get tan inverse of 1.5 is equal to 56.3 degrees. 56.3 degrees. Okay. Yes. 56.3. Now, then I have given yesterday one relation. Psi is equal to what? Phi minus R plus delta. Psi is equal to phi. Minus is for lagging power factor. Plus is for leading power factor. Okay. Yes. Psi we know 56.3 degrees. Then phi how much? Or first let me write. Psi is equal to what? For leading power factor means psi is equal to phi plus delta. Therefore, delta is equal to psi minus phi. Psi is 56.3 degrees and phi is 36.86 because 0.8 lag means 36.86. That is equal to how much? Delta is equal to, you will get 19.44 degrees. 19.44 degrees. And once you know the delta, calculate ID also. ID. What is ID? ID is equal to IA sin psi. ID is equal to IA sin psi. That IA is equal to how much? Rated current. Full load current means rated 1 per unit. Current to be taken 1 per unit. Sin psi. Sin psi means 56.36. 56.3. How much it will be? ID is equal to 0.831. 0.831 per unit. IQ is equal to IA cos psi. IA cos psi. 1 into cos 56.3 degrees. That is equal to how much? You will get 0.544 per unit. Okay. Then we know E is equal to V cos delta plus IQRA. IQRA not plus, I'm sorry, minus, no, synchronous motor. V cos delta minus IQRA minus R plus IDXD. Equations are very important. So therefore, substitute V is equal to what? Minus is for lagging power factor, plus is for leading. So V is equal to 1 into cos delta, how much? Delta 19.44. Of course, this is 0, IQRA, but leading means plus I can use. ID how much? 0.831 into XD. XD is equal to 0.8. So what is that value? you will get 1.608 per unit. Therefore, what is the answer? Answer is E is equal to 1.608 per unit. That is your answer. Okay? Yeah. For this question, if you are having very thoroughness, it may take around 2 minutes. 2 minutes definitely it will take. But thoroughness, calculator should be pakka, very fast operation. Virtual calculator, na, you need to operate very fastly. That comes by practice only. Okay. Yeah. Okay. Yes. Yeah. What is your doubt? Tell me. Hello. Hello. You have raised your hands. Tell me. Hello. Hello.
Hello, sir.
Tell me.
Hello, sir.
Hello.
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 Hello. Sir, why we haven't used the equation E under root V cos?
How can you get that equation? This is XD XQ, na?
Okay, sir.
Salient pole. Cylindrical, you are correct.
Okay, sir. Okay. Thank you, sir.
Salient, so XD XQ will comes into picture, na?
Okay, sir.
That's the reason yesterday I have given for both salient poles separate in the table. There you have to use E is equal to V cos delta. This is magnitude. It becomes magnitude. That is also magnitude, but that is valid for cylindrical rotor synchronous motor value.
Okay, sir.
Right.
Okay,
Right.
thank you, sir.
Okay. Right. Hello. 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 Okay. Now, next question. Next question is, I will give one question from GATE 2017 examination. GATE 2017 examination question. A three-phase 50 Hz star connected cylindrical rotor alternator. Cylindrical rotor alternator. Cylindrical rotor, not alternator. Cylindrical rotor synchronous motor. Cylindrical rotor synchronous motor. Line voltage is 6.6 kV. 6.6 kV. Is drawing current at UPF. Is drawing current at UPF, and XS is equal to 3 ohms. XS is equal to 30 ohms. XS is 30 ohms. Delta is 30 degrees. 30 degrees. Then power is how much? Power is equal to dash. Power. Very simple. At the same time, logical question. Dear students, logical question. For 2 marks he has given. 2 marks question means, see, a three-phase 50 Hz star connected cylindrical rotor synchronous motor, line voltage 6.6 kV, drawing current at UPF, XS 30 ohms, delta 30 degrees. Then power is how much? Yeah. First of all, you know, power is equal to EV by XS sin delta. Na? So power, if you want to calculate EV by XS sin delta, you will think about this relation. Okay. But in this, E has not given. E to be calculated. E has to be calculated. E has to calculate. E don't know, na? We don't know E. So how to calculate E? Tell me. How to calculate E? E is equal to V cos phi plus IARA whole square. V sin phi plus Ia xs whole square. We are trying like this. E is equal to V cos phi, okay, minus Ia Ra whole square plus V sin phi minus Ia xs whole square. Can you calculate? Because we don't know Ia is unknown. Ia is not given. So in this, Ia is not given. Ia is not given. Okay. Then how to calculate? How to calculate E? I want E immediately. E can be calculated one condition. Important thing here in this problem is UPF is given. Power factor is UPF. Delta is given. Power factor is given. Delta is given. At UPF, E cos delta is equal to V. That is given. E cos delta is equal to V. So E I can calculate now. So what is E? Then E is equal to, I can calculate V by cos delta. V by cos delta. At UPF normal excitation, E cos delta is equal to V. That is for what? Normal excitation. That is for normal excitation. Normal excitation. It is operating at UPF is given, power factor is given UPF. E cos delta is equal to V. Therefore, what is E? E is equal to V by cos delta. V is equal to how much? V per phase you calculate. Always we need to calculate per phase values. V is equal to 6600 divided by √3 per phase divided by cos delta. Cos delta how much? Cos 30 given. No? This is some value. Cos delta. Okay. E value. E value is equal to, you will get 4400 volts. 4400 volts. Fine. Once you know the delta, then what is the power? Power, total power. You have to calculate always power, total power. Nothing is given, calculate total power. If it is saying power per phase, then only you calculate power per phase. So therefore, 3 into EV by XES sin delta, I can calculate total power. But inside of that, 3 into EPH, 4400 into V how much? 6600 divided by √3 divided by XES. XS how much? 30. 30 into sin 30. That value is how much? It comes around 838.31 kilowatts. Okay, this is the question. In this logic is E cos delta is equal to V. That way you can calculate E. Otherwise, there is no IA is not given. Yes. Okay. But in equation, dear students, see always power equation you are using. Power per phase aithe EV by XS sin delta. But E will be per phase, V will be per phase, XS anyhow per phase. If you want to total means 3 into EPH into VPH. Per phase values. I am using always per phase values. So total power means 3 I am multiplying. Okay. Yes. In the question, always you need to calculate total power. Total power. Or for 3 phase. If it is given power per phase, that is okay. Otherwise, total power. Similarly, okay. See, next question. For each model, I am doing one. I'm not doing all gate problems, not necessary. But to have the idea, I am giving one question. See, another previous gate 19 examination. Gate 19 examination question. A 200 volts, a 220 volts line. A 220 volts line, 3 phase, star connected synchronous motor. Synchronous motor has ZS is equal to 0.25 plus J 2.5 ohms. J 2.5 ohms per phase. per phase. The motor draws the rated current of 10 amperes at 0.8 leading power factor. At 0.8 leading power factor, then EL is equal to line voltage, EL is equal to dash. He has given line voltage, particular is asking line voltage. Line voltage, how much? Line voltage. Yes. The solution, first calculate. V line is given at 220 volts. Star connection. Therefore, what is V phase? 220 by root 3. 220 by root 3. How much it is? 127 volts. V phase is 127 volts. And now ZS is how much? See, ZS. ZS is equal to 0.25 plus J 2.5. ZS is equal to RA plus JXES. 0.25 plus J 2.5 ohms per phase. And therefore, RA is equal to how much? 0.25 ohms. XS is equal to how much? 2.5 ohms. All they are per phase. So rated current 10 amperes. Now you calculate E value. Power factor is given. Now what is the power factor? 0.8 leading power factor. IA also given 10 amperes. E calculate. But this is E per phase, whatever we are calculating. Substitution per phase. V cos phi minus IA RA whole square. Now I can use cylindrical machine. This is IA RA square plus V sin phi plus or minus na minus or plus IA XS whole square minus for lagging power factor, plus is for leading power factor. Leading power factor. Okay. So substitute here V cos phi. V is equal to 127 per phase values I am substituting. Cos phi how much? 0.8 leading minus IA 10 into RA 0.25 whole square plus V sin phi 127 into 0.6, but it is leading means plus 10 into 2.5 whole square. What is that V value? That is equal to 141.64 volts. 141.6 E phase. That is E phase. Always in the equation substitute per phase values only. Every voltage, current to reactance, everything, because reactance resistance given per phase. So all other things will be per phase. Then what is the line voltage? Line voltage is equal to root 3 into EPH. Root 3. So root 3 into 141.64. That is equal to how much? You will get 245.32 volts. That is answer. This is answer. Your answer is 242. Okay. How much time it will take? Hardly one minute or 2 minutes roughly. Say 1.5 or 2 minutes it will take. But this relation I have explained na. Wherever possibility is there, I don't want to use the J terms, etc. But somewhere definitely you need to use J terms. If this equation E is equal to, you can also get E is equal to V0 minus IA. You will also get it. E is equal to V minus IA ZS is there now. With that also you will get it. But V0 IA at an angle plus or minus phi, ZS at an angle theta. These terms, what will happen? It may take conversions are required. That's the reason wherever possibility is there, magnitude equations these are. Yeah. Yes. Now, I want to give one question from last year GATE examination, GATE 2021. For each model, one question, GATE 2021. For 2 marks. Question is, an alternator with the internal voltage, an alternator with the internal voltage of 1 at an angle delta 1 per unit, 1 at an angle delta 1 per unit, and synchronous reactance of 0.4 per unit is connected by a transmission line. A transmission line reactance 0.1 per unit, 0.1 per unit to a synchronous motor. Having synchronous reactance of 0.35 per unit, and internal voltage of 0.85 at an angle, 0.85 at an angle delta 2 per unit. Okay. If the real power supplied by the alternator, real power supplied by the alternator is 0.866 per unit. Okay, yes. Then delta 1 minus delta 2 is dash degrees. That is a question. Delta 1 minus delta 2 is how much? Okay. See the question first of all. Try to understand the question clearly. Okay. Yes. Yeah. So the question is, this is a synchronous reactance. And there is a reactance. Transmission line, this is a synchronous motor. Both are connected. synchronous reactance have XS1. For example, say this is XS1 is equal to how much? 0.4 per unit. He has given reactance of XS1 is equal to 0.4 per unit. And this is XS2 is equal to synchronous motor. This is alternator. This is synchronous motor. XS2 is equal to how much? 0.35 per unit. And XT is equal to 0.1 per unit. And this is E1. E1 at an angle is alternator, no? Alternator, this is synchronous motor. E1 at an angle, E1 is equal to 1 at an angle, delta 1 say, delta 1 he has given. And this is E2 say, E2 is equal to how much? 0.85 per unit at an angle delta 2 per unit, okay? And power transmission, power is transmitting from alternator to motor. How much power? 0.866 per unit is given. Okay, per unit. Then what is the delta 1 minus delta 2? See, it is a network, no? Total reactance is in series. He is giving single line diagram. So power is equal to what? E1 into E2. EV by X is sin delta. We have given a sin delta difference. E1 by E2 into total reactance. Total reactance how much? XS1 plus XS2 plus XT. Total reactance. XT you have to take. Total reactance. So in the circuit, if network, if you use XS1 plus XT plus XS2 into sin delta 1 minus delta 2, dear students, delta 1, delta 2. Because earlier we have taken V at an angle 0. V at an angle 0, E at an angle delta. Therefore, delta minus 0 is equal to delta. But when two things are there at an angle delta, so it will be delta 1 and delta 2. Therefore, power is given 0.866. That is equal to E1 how much? E1 is equal to 1. E2 is equal to 0.85. 0.866, no? 0.85 divided by XS1, 0.4 per unit, and XT, 0.1 per unit, plus 0.35 into sin delta 2, delta 1 minus delta 2, delta 1 minus delta 2 is equal to, this is both are same now, yes, 0.85 divided by 0.85 totally, 0.85 into sin delta 1 minus delta 2. Okay, therefore sin delta 1 minus delta 2 is equal to 0.866. Therefore, delta 1 minus delta 2 is equal to how much? Sin inverse of 0.866. How much it is? 60 degrees. Sin 60. Therefore, delta 1 minus delta 2 is equal to 60 degrees. That's the answer. Therefore, delta 1 minus delta 2 is equal to how much? 60 degrees is your answer. This is the question. Okay. Right. Okay. Now, let us see another question. Yeah. The last question, gate question I will do, and next we will go to the some other type of questions. I have given the material, I want to do some problems. Okay, see. Question is very important question. This came so many times. GATE examination he has asked. GATE 2008 examination he has asked for 4 marks. 4 marks. Similarly, GATE 2015 also similar question. GATE 2012 also same question. Similar question. Similar question. Right? See. The question is similar question. GATE 2008. Similar question in GATE 2012, GATE 2015 also. 15 also. Okay. So the question is like this. A synchronous motor is connected to a synchronous motor is connected to infinite bus at V is equal to 1 per unit. At V is equal to 1 per unit. IA is equal to 0.6 per unit at UPF. At UPF and XS is equal to 1 per unit. RA is equal to 0. RA is equal to 0. Okay. Then E is how much? Question number, first question. Then question number 1. E is equal to how much? And second question is keeping excitation constant. Keeping excitation constant. The load on the motor is increased to. The load on the motor is increased to. The load on the motor is increased to. Increased such that motor current is increased by. Motor current is increased by 20%. 20%. Then the power factor will becomes. Then the power factor will be dash. Power factor will be dash. Good question. Okay. So see, synchronous motor is connected to infinite bus bar. V is equal to 1 per unit, IA 0.6 per unit. E. Can you calculate E value? How you can calculate E? E is equal to synchronous motor. E is equal to what? V cos phi. Okay. Minus IRA whole square plus V sin phi minus R plus IA XS whole square. But it is UPF. Minus for lagging power factor. Plus is for leading power factor and UPF. Leading and UPF. It is given UPF. First question. I am solving first part. Substitute here. V cos phi. V is equal to 1. 1 per unit is given. Now. Power factor is also 1 is given. RA neglected. That is 0. Whole square. Okay. No, sorry. IA is equal to 0.6 now. 0.6. 0.6 into RA 0 whole square plus V sin phi 1 into that is 0 sin phi 0 plus IA 0.6 into XS is equal to how much? XS is equal to 1 whole square. So what is that E value? E value you will get 1.116. 1.116 per unit. This is answer. Over. How much time it will take? Only one step, na? Yes. Next. Next, second question. Second question. Keeping excitation constant, load on the motor is increased. Excitation constant, but when load increases, what will happen? Delta increases, na? Synchronous motor, E shifting, delta increases, current increases, power factor also changing. What will becomes power factor? Tell me. Right now it is UPF. When load increases, it will come to the lagging side. Power factor is going to be lagging. It will come this side, na? Yes, lagging side. And is asking, when load is increased such that current is increased by 20%, current increased 20%, current is giving, then you need to calculate power factor. Let us see. Excitation is kept constant. Since excitation is kept constant, therefore E constant, E is constant. E constant, that is equal to how much? 1.116 per unit only you have to take. E to be taken constant. E is a, right? Yeah. E is a. But when current is increased, when load increased, then delta increases, current also increases. But the current is given how much? 20% is increased. That IA is equal to 1.2 times of IA. IA how much? 0.6. So therefore, what is the current? Current is equal to 0.72 per unit. Now it becomes 0.7 per unit. Then what is the power factor? Is how much? Power factor how much? So what is there in our hand? You know E value, current value you know. Okay. Then you have to calculate power factor. How to calculate power factor? Okay, power factor. IA you know. Power factor we don't know. Power factor has to be calculated. See, whenever you want to calculate power factor, best thing is see, calculate the current. Again, once again, whenever power factor is asked, I will do one thing. Calculate the current. IA is equal to what? IA is equal to V0 minus E minus delta by ZS at an angle theta. This is the current. V minus E by ZS, but V0, what is the E? Delta minus delta. ZS divided by theta for synchronous motor. That is equal to what is V? V is equal to how much? V is equal to 1 per unit. 1 at an angle 0. E how much we have got? E is equal to, oh sorry, we don't know that power, na? Power we don't know. Delta we have to calculate, na? Delta we have to calculate first of all, dear students. Delta has to be calculated because we don't know. IA we know magnitude. IA we know. So instead of that, this equation, best thing is magnitude equation. E is equal to how much? E is equal to 1.116. 1.116 at an angle minus delta, we don't know delta, and ZS we know. ZS is equal to how much? 1 at an angle 90 degrees. 1 at an angle 90 degrees. This is equal to how much? This is equal to 0.72 per unit. 0.72. Now you can calculate delta. Delta is equal to how much it will come. Okay. Instead of that, or simplest thing you see, or magnitude equation is there, na? Magnitude in the sense IA into ZS. We know IA into ZS is equal to drop is equal to na? V is equal to, see, E is equal to V is equal to E plus IAZS. V is equal to E plus IAZS. Then IA is equal to IAZS is equal to IAZS. Magnitude is equal to V minus E. But that is equal to what? V0 minus E minus delta you have to use. Not just it is magnitude. No. No. This is correct. V0 minus E minus delta. But that V minus E minus delta is equal to, you have to convert that into A vector and B vector. Na? This is A vector, this is B vector. I can write that is equal to V square plus E square minus 2VE cos delta. We remember A square plus B square minus 2AB cos delta. These are the two phasors, no? Two phasors. Remember this relation. IAZS, very important relation, dear students. V square plus E square minus 2VE cos delta. Now delta I can easily calculate. Magnitude, magnitude. IA is given. IA how much? 0.72. ZS how much? ZS is equal to 1. What is V square? V1 square. E square how much? 1.116 whole square. Minus 2 into V1. E 1.116. Cos delta is unknown. Therefore, now you calculate delta. Delta. Delta is equal to 37.85 will get. 37.85 will get. There is a delta value. 37.5. When that is delta, then calculate IA once again. IA is equal to V0 minus E minus delta divided by ZS. Okay. V how much? 1 at an angle 0. E 1 point at an angle 116 at an angle minus 37.85. Definitely here you have some conversions are required. ZS is equal to 1 at an angle 90 degrees. That you will get IA is equal to IA magnitude once again you will get 0.7. Current you know already, but it will get same thing. IA at an angle how much? Angle is 6.31. Minus 6.31 unit. This is itself 5. Therefore, power factor is equal to cos 5. .994 lagging. Okay, this is your answer. Okay. Yes. So these are the type of problems. I don't want to do all the problems. I have done some sample problems. After the break, we are going to some other problems, not gate problems, some general problems I will do it. Okay. So let us take break. Maybe time to better to take break for right. Then after that, what is Mahesh? Tell me. Just a minute. Only 2 minutes. Mahesh, tell me what is your doubt? Yeah. You raised hands. No one is there.
Sir, how we will get a 1.2, sir?
1.2.
1.2, sir. In this problem only.
20% increase in he has given. This is increased by 20%.
Okay.
Increased by 20% means IA dash will be 1.2. That's the reason I have given 20% increase.
Okay, sir.
It is 20% increased.
Okay, sir. Thank you.
20% increase. Okay. Let us take break for some time. Then after the break, we are going to continue. Break for 15 minutes. And today we are going to complete our syllabus. Break for 15 minutes. సరే అతనికి ఇప్పుడు ఇంత టెన్షన్ పడుతుంది. how it is lagging. Some questions from the students, we not calculated E for increased value of current. Increased value of current, there he has given excitation is kept constant, na? Excitation constant. But when load increases, delta increases. Delta increases. I think your doubt may be this one. This one, na? E constant, Y constant, excitation is constant. Since excitation is constant, E constant only, na? Second case, we have seen synchronous motor. When load increases, E will be shifted. Current magnitude increases. When load increases, delta increase, current is increasing. That's what. Current increases. E same. And some of the students are asking why it is lagging power factor means since phi is minus, lagging because phi is negative. Phi is negative. That's the reason it is lagging. Therefore, lagging. Lagging means when you are getting angle minus, lagging. Okay. Dear students, when you are getting that is angle is minus. Again, we are going to see, of course, so many questions, remaining questions we will see. Yeah. Now, next questions. So I would like to do the questions first from whatever I have given material for you now. Yes. For each model, again, let us do one problem. Let me share. See. I'm sharing this. Okay. Yes. Sorry. I hope have got this questions in your booklet. Yeah. I think the whatever booklet is given for you now, this book. Okay, I'm showing that questions PDF. If you don't have that questions, please let me know. I will send that file also. If you want that file, I will send it. Only question file, whatever I am sharing. So that is same question number and everything which is given in this booklet. Okay. So let us do problems mainly based on the synchronous motors. Synchronous motor starting from 64. Question number 64. Question number 64. See this question. Question number 64. Question number 64. What is that? A 480 volts, 60 hertz, 4-pole synchronous motor is drawing 50 amperes of current at full load and unity power factor. Assume that the motor is lossless. The output torque of the motor. Torque to be calculated. See, IES examination is asking particularly torque calculation. Simple. Torque is equal to power by omega. Na? Torque is equal to simply power by omega. Let us do this problem. Okay. I hope you have taken the data. Na? Right. See. Torque is equal to power by omega. Torque is equal to power by omega. Question number 64. 64. A 480 volts. Data what is given? A 480 volts. 60 hertz. 4-pole synchronous motor. 4-pole synchronous motor. It is drawing 50 amperes. drawing, current is equal to current IA is equal to 50 amperes. 50 amperes, full load, at full load. And what power factor? UPF, unity power factor. Assume lossless. And torque of the motor is how much? What is the torque? Okay. What is the torque? You have to calculate. Torque is equal to how much? Torque is equal to power by omega. Torque is equal to power. Calculate power. Power is equal to right, root 3 VLIL cos phi. It's a star connected. Unless otherwise given, you need to take always star connection. In this, what is the data given? Line voltage. He has given line voltage. VL is equal to 480 volts and current I is equal to 50 amperes. Then power input is equal to root 3 VLIL cos phi. Root 3 VLIL cos phi. So root 3 VL is how much? 480. IA 50. Star connection means line current, phase current same. IA phase is equal to IA line. Assume star connection. Assume star connection. If it is nothing is given, you need to assume always it is star connection only. Star connection. So root 3 VLIL cos phi. Cos phi how much? 1. Okay. So that power is equal to, yeah, your power is equal to calculation 415 41569 569.2 watts. Okay, that is the power input. Then torque is equal to what? Power by omega. Power by omega. Power is 41569.2 divided by omega 2 pi n by 60. Omega 2 pi n by 60. Angular speed. Some students are asking, sir, omega is equal to 2 pi f. That is angular frequency. This is angular speed, rotation. 41569.2 divided by 2 pi. 2 pi n is how much? 4 pole 60 hertz means 1800. Na? 1800 by 60. That is equal to how much? That is equal to 220.53. 220.53 Newton meters. That is the answer. Okay. Yeah, I think you can calculate it. N is equal to how much? 120 into F by P. 120 into F, frequency is 60, 4 poles. That is equal to 1800 RPM. That is the speed I am using here, N. So therefore, what is your answer? Answer, torque is equal to 220.53 Newton meters. This is answer. Okay. Now, similarly, next question. Next question. '65. See question number 65. Question number 65, dear students. Question number 65. 65, a phasor diagram of synchronous machine. This is your previous ESC examination. The phasor diagram of a synchronous machine connected to an infinite bus is shown in figure, above, not above figure, in below figure. Okay. Below figure. The machine is acting as, how this machine is acting as, tell me? Is it acting as a generator or motor? Generator or motor? Is it lagging power factor, leading power factor? Vectors are rotating counterclockwise. Vector rotation is given. There is a counterclockwise direction. Tell me, generator or motor? It is a generator. Why generator? Why generator? Because E leads V, E leads by 30 degrees. That is a generator. Then is it operating at leading power factor, lagging power factor means E cos delta you have to say E cos delta greater than V means lagging. E cos delta less than V leading. Right? Yeah. See, question number 65. Have seen diagram is given. Question number 65. Simply has given a diagram. This is V. V is given. No? And E is given. V is equal to 1 per unit. But E is equal to how much? E is equal to 1.5 per unit. E is equal to 1.5 per unit. This is delta. 30 degrees is given. Phasors are rotating. Therefore, we can say, since E is leading, E leads the V by 30 degrees. Therefore, generator operation. It is generator operation. Generator. But E cos delta greater than V or less than V, you have to calculate. E cos delta is equal to how much? E cos delta is equal to 1.5 into cos 30. That is equal to, what is that value? E cos delta. Its value will be E cos delta. Yeah. 1.5 into 30. Definitely it will be greater than V, na? Definitely this whole thing will be greater than V because V is equal to 1 per unit. 1 per unit. Therefore, what is the power factor? Since E cos delta greater than V, over excitation. For over excitation, what is the power factor? Therefore, lagging power factor. Lagging power factor. So, generator operation, generator at lagging power factor. Generator at lagging power factor. This will be. Okay. Generator at lagging power factor. Fine. If my question is, if it is delta is 60 degrees, say, if delta is equal to 60 degrees, delta 60 degrees, then what is its power factor? Tell me. Delta 60 degrees. Now you calculate E cos delta. That is E is equal to 1.5 into cos 30. Cos 60 is equal to how much? Cos 60. Then you will get it is 1.5 into 0.5 is equal to 0.75. That will be less than V, 1 per unit. Then it is going to be leading power factor. Then it is operated leading, even though E is same. Okay. E is same. Correct? Yes or no? Okay, page number. Yeah. I will give the page numbers for this question. Dear students, 244. This question is page number 244. Page numbers 244. From 243 onwards, 243 onwards, this is page number 243. Earlier question is there, na? That will be page number 243. Page number 243. Page number 243. Okay. Generator lagging. Very good. 1.29. This value 1.29. Yes. Very good. Yeah. Good. Nice. Fine. Good response from you people here. So very nice for the teaching with you people. So your response is very fast when question is being given. People are asking very good doubts also. Very happy. I'm very happy. So we expect good ranks from you people. And any doubts are there, of course, from last some people I used to answer, some people I may not be, but from tomorrow onwards I will be free, because this class I am engaging, and morning also I am taking physical class 6 to 8, and evening is 5:30 to around 9:30 it is going, and even doubts are there 10 it is going. And I also busy in the college. So in the last week, because due to inspection, some inspection was there. That's the reason. Yeah. For some people, I could not able to answer. I think, of course, I may be given a late answer, but tomorrow onwards, I am free. The afternoon session, I am free for a few days. Okay. You please ask any doubts. I will reply. I will reply. Okay. Not on the same day or next day. I will try to tomorrow onwards. I will try to give the response on the same day itself. On the same day itself, because I don't have any class in the afternoon session tomorrow onwards. I think it may be from at least it's not yet confirmed, but no issue. So 3-4 days are there now. Within 3-4 days, you can ask any doubts. I will reply. Okay. Don't think class is completed today. Sir is not with you. Don't think like that. I have given my number now. Once again, I am giving my number. My number is, write down, 9849719672. If required, I will call also. I will call you also, because some questions cannot be answered just in the typing in the WhatsApp. Okay. If required, I will call you people also. Or else I will say you can call someone so and so time. Right? So I will explain. Then we are having all overall idea. With the explanation, you can able to understand. Okay. If required, I will write in the paper also. I will give the photo. Don't worry. So your preparation is important for us, and your rank is important. Correct? Who is the first beneficiary? You are the first beneficiary. If you get good rank, say you are the first beneficiary, your parents will feel proud. After that, we will also take credit. Yes, our students got good rank. Right? Yes, that is only the happiness for the teachers. So more successful students are there, then automatically we will enjoy the success. Your enjoyment is also our enjoyment. No? So I wish you definitely, so very good ranks we will expect. Right? And any doubts are there, you are always welcome. Okay, let us continue our questions. Fine. Yeah, same page number. Page numbers will be from 2 part 3. Synchronous motor is there, no topic from there onwards. Yeah. Now I am continuing 244 page number. Question number 66. Question number 66. Now let us see question number 66. See this question 66. Yeah. 66. Page number 66. Sorry, page number 244. Question number 66. A 8-pole 50 Hz. A 8-pole 50 Hz 3-phase synchronous motor and an 6-pole 50 Hz 3-phase slip ring induction motor are mechanically coupled and operate on the same 3-phase 50 Hz supply system. If they are left to open circuited, then the frequency of the voltage produced across any two slip rings would be 8-pole 50 Hz 3-phase. The synchronous motor and induction motor both are mechanically coupled. Both are mechanically coupled, operate on the same 3-phase supply. Both are connected in parallel and mechanically also coupled. Both are operating 50 Hz frequency. But synchronous motor poles are 8 poles, so induction motor poles are 6 poles. The slip ring induction motor. Then what is the inducer? These questions are very common. Very simple also, nothing is there. Yeah. See? Question number 66. Page number 244. Okay? Yes. 8 pole, in this 8 pole synchronous motor, both are connected in parallel. The synchronous motor, this is a synchronous motor, say, and this is induction motor. Induction motor, both are operating same three-phase supply and both are also mechanically coupled. This is synchronous motor and this is induction motor. Both are mechanically coupled. But induction motor is a slip ring induction motor. Slip ring induction motor. Slip ring induction motor. This is operating on which frequency? 50 Hz frequency. Okay, this is 50 Hz frequency. Induction motor poles 8 poles. Synchronous motor poles. And this is 8 poles, no? 8 poles. Okay. Both are mechanically coupled. The synchronous speed ns, synchronous motor, ns is equal to how much? 120 into F by P. That is equal to 120 into frequency. F is equal to 50, poles 8 is equal to how much? Its speed is 8 poles means 750 RPM. Synchronous motor speed is 750 RPM. When that is 750 RPM, then what is the speed of synchronous motor, induction motor? Induction motor speed also will be 750 RPM. 750 RPM because the set will rotate. Set will rotate. And the synchronous motor is rotating at 750 means induction motor also should rotate with the same speed. The set will rotate with the same speed as speed of synchronous motor. The same speed as synchronous motor. Synchronous motor speed. Because both are mechanically coupled. Since both are mechanically coupled. Both are mechanically coupled. Okay? Yeah. Since both are mechanically coupled means their speed is same. NR. But what is NS? NS of induction motor 120 into 50 by 6 poles. It is 1000 RPM. No? 1000 RPM. 1000 RPM. Then slip of synchronous motor, induction motor, NS minus NR by NS. That is equal to NS is 1000. 1000 minus 750 by 1000 is equal to how much? 1 by 4. 0.25. Slip is 0.25. 0.25. Then what is F dash? F dash is equal to SF. Na? The frequency induced in the induction motor. Rotor winding. Slip times of frequency. So therefore, rotor frequency F dash is equal to SF. S is 0.25, F is 50, is equal to how much? 12.5 hertz. That is the answer. 12.5 hertz. Only important thing here, at what speed synchronous motor rotate, induction motor will rotate with the same speed. Induction motor rotate with the same speed. Right? Right now, how the machine is acting like induction motor, na induction motor rate. Because rotor speed is less than. Now I may ask a question. Question is, if it is synchronous motor is 4 pole motor, say 4 pole motor means its synchronous speed will be 1500. Then induction motor also will rotate 1500 RPM only. 1500 RPM it will rotate. Now it acts as an induction generator. Actually its synchronous speed is 750, no? Synchronous speed is 750 RPM. Sorry, 1000 RPM. 1000 RPM. But it is, if it is synchronous motor speed 1500, it is rotating more than synchronous speed. Induction generator act as induction generator. Okay. Now it will deliver its power to the grid. Motor is acting as a prime mover for this. Okay. Yeah. But only thing is, for synchronous motor, any other motor is connected, set will rotate with the same speed as that of synchronous motor. That is the main key point here. Okay. Now, then coming to the another question, 67. Question number 67. This you have taken? Yes. Next, question number 67. Very important question. 67. Very popular question. Well-known question. Important question. Expected type of question. Okay. This type of questions you might have seen already. Power factor correction. An industrial system has, okay, an industrial system has a load of 100 kVA, 100 kVA at 0.6 power factor lagging. Industrial load 100 kVA, 0.6 power factor lagging. Now, a synchronous motor is added to the system to improve the overall power factor. A synchronous motor is connected to improve the overall power factor. If the synchronous motor is operating at 10 kilowatt and 0.5 power factor leading, then the overall power factor of the system is 0.8 lagging, 0.74 lagging, 0.99 leading, 3.9 leading. Okay. This is power factor correction type of problems, no? Yes. Right. Now let us see the question solution for this. Question number 67. I hope you understood the question, na? Yeah. This is also page number 244. Question number 67. Question number 67, page number 244. In this, an industrial system has a load of, this is industrial system, say. Industrial system has a load of, this is a load. Industrial load. Load of 100 kVA. This is 100 kVA at what power factor? 0.6 lagging power factor. 0.6 lagging power factor. And the induction motors. Nothing but it is induction motors, no? Yes. Industrial load. It is 0.6 lagging. It is drawing 0.6 lagging power factor. Now to improve the overall power factor. Now system is operating at 0.6 lagging. To improve the overall power factor, a synchronous motor is connected. A synchronous motor is coupled. Synchronous motor is coupled. It is also loading. Load on the synchronous motor also there. So it is taking the power of how much? Operating. Its power is equal to synchronous motor power is 10 kilowatts it is taking. 10 kilowatts it is taking. 10 kilowatts. Operating at 0.5 leading power factor. 0.5 leading power factor. Leading power factor. Okay. Yes. Then what is the overall power factor of the system? How much? Overall, after connecting synchronous motor, what is the overall power factor? The plant power factor, how much? Before connecting, its power factor is only 0.6 lagging, no? 0.6 lagging industrial load. But now synchronous motor is connected. What is the overall power factor? See, that overall power factor in this power P1 say, P1 is equal to kVA into power factor, na? kVA into power factor, right? That is equal to how much? 100 into 0.6 is equal to how much? 60 kilowatts. 60 kilowatts. And Q1 is equal to P1 into tan phi. Q1 or else Q1 is equal to kVA into sin phi. That is kVA how much? 0.6. 100 into 0.6. Sorry, 0.8. Q1 is equal to kVA into sin phi. Okay. kVA into sin phi. That is kVA into cos phi. So kVA is equal to how much? 100. Sin phi is equal to 0.8 because cos phi is equal to 0.6. Cos phi is equal to 0.6 means it will be sin phi. Right? And its power factor how much? Phi is equal to 53.13 degree. 53.13. So it will be 0.8. Sin phi is equal to. So what is the Q1? Q1 is equal to 80 kVAR. 80 kVAR, but it will be lagging type. Lagging 80 kVAR. Whereas for synchronous motor, let us take this is P2. P2 which is taking 100 kilowatt. Phi 0.5 leading means phi is equal to 60 degrees. 60 degrees. Then what is Q2? Q2 is equal to P2 into tan phi. Q2 is equal to P2 into tan phi. Correct? Yes. Why? Because from power triangle, for example, this is P say. This is P, this is Q, this is S. Yes. Okay. This is phi. This is phi. Right? Now, if you want tan phi is equal to what? From this. Tan phi is equal to tan phi. Tan phi is equal to Q by P. Q by P. Therefore, if you want to calculate Q, P into tan phi. P into tan phi. P into tan phi. So therefore, that's the reason I am writing that is equal to simply P2 into tan phi. Now what is P2? 10 kilowatts. 10 kilowatts into tan phi is equal to tan 60. Tan 60. That is equal to how much? Q2. Q2 is equal to 17.32. That is 17.32 kVAR. 17.32 kVAR. Leading. It is leading. Leading. Therefore, now finally total kVAR is equal to how much? Total P. Total P is equal to P1 plus P2. Total P is equal to P1 plus P2. P1 is equal to how much? P1 is equal to 60. P2 is equal to 10. That is totally 70 kilowatts. 70 kilowatts. Total Q how much? Total Q is equal to Q1 minus Q2. Because that is lagging, this is leading. Leading. So it is equal to 80 minus 17.32. 17.32. Okay. Yes, that is equal to 62.68. 62.68 kVAR. Resultant is lagging only. Okay. And once you know the Q and P, then I can calculate phi. Phi is equal to tan inverse of Q by P. So tan inverse of Q is equal to 62.68 and power is 70. Therefore, what is phi value? Phi is equal to 41.842 degrees. 842 degrees. Then overall power factor. Overall power factor is equal to cos phi. So that is equal to cos 41.842 is equal to 0.74 lagging. 0.74 lagging. Okay. That is the answer. 0.74 lagging. Remember that very important questions. This is very important question. 0.74 lagging. Correct? Tell me, Mahesh, what is your doubt? Mahesh, you are raising your hand. Hello, Mahesh. Mahesh, tell me.
Hello, sir.
Yeah, tell me, any doubt?
Want to draw phasor diagram, sir.
Why phasor diagram? Okay, you want phasor diagram?
Yes, sir.
Okay.
Okay.
Phasor diagram for this. So take this now over. Yes. Yeah. So this is P. It is a power triangle. This is your kVA. How much? 100 kVA. 100 kVA. But you'll have both. First it is lagging, na? It is lagging. How much it is? 100 kVA. 100 kVA. P how much? This is P1. P1 is equal to 60 kilowatts. And this is Q1. Q1 is equal to how much? 80 kVA. Lagging. Lagging. So of course this is 100 kVA. 100 kVA. Now to improve the overall power factor, we are connecting synchronous motor. Synchronous motor also it is taking active power of P2. That P2 is equal to how much? 10 kilowatts. P2 is equal to 10 kilowatts. And it is delivering leading kVA. How much? That is equal to 17.32. 17.32 kVA leading. Okay? Yes. Now what is the overall? This is phi, na? Phi. Phi is equal to how much? 63. It is 53.13. 53.13 degree. This is 60 degrees. 60 degrees. But by adding these two, what is net power? Net is equal to P1 plus P2. Na? Yes, P1 plus P2. That is equal to 70 kilowatts. This is 70 kilowatts. But resultant is, it is reduced. How much it is? 80 kVA minus 17.32. That is equal to how much? That is equal to 62.68. 62.68 kVA. Lagging. So then you will get, this is the overall. This is kVA. Now this is the phi, overall power factor, this is the phi. That phi is calculated. Tan phi is equal to opposite side, 62.68 divided by 70. Correct? 62.68 divided by 70. So therefore, then phi you will get. Phi is equal to tan inverse of that. Phi is equal to, what is the phi? 41.48. 41.48. Then power factor is equal to overall power factor. Is cos 41.48 is equal to how much? 0.74 lagging. 0.74 lagging. Okay. And sometimes kVA rating of synchronous motor, kVA synchronous motor is equal to square root of 10 square plus 17.32 kVA. Fine. Taken? Okay. Now, let us see another questions. Yeah. Okay. See, at the end, I am going to discuss another important topic. It is a matter of some 20 minutes topic, already known thing. When related to reluctance motor, reluctance generator, all conclusions. let me complete few problems I would like to do. Okay. And exactly, yeah, it may take the problems another some 15 minutes like that. After that, I will start the topic. So all 7 questions on that, 7 questions, varieties of questions, but all this already we have discussed type of things. Okay. Yeah. Now, let us do the question number 69, 70, 71, 69 to 71. 69. Very simple question, very important questions also at the same time on synchronous motor. 69 to 69, 70, 71. 69, 70, 71. A 3-phase star connected 400 volt synchronous motor takes a power input of 5 kilowatts at rated voltage. Its synchronous reactance is 10 ohms. 3-phase star connected 400 volt synchronous motor takes a power input of 5 kilowatt at rated voltage. Its synchronous reactance is 10 ohms per phase. Resistance is negligible. If excitation voltage is adjusted equal to the rated voltage, then what is the load angle? What is the power factor? Okay. What is the power factor? And what is armature current? Armature current also. Armature current. Yes. See. Question number 69, 70, 71. In page number 243, 244. Okay. Let us do this. Anyhow, I am writing the data there also. In brief, I am writing the data. You can correct, you can check that. Okay. See the question number 69, 69, 70, 71. Page number 244. Page number 244. What is the question is given? A 3-phase star connected 400 volts synchronous motor. Synchronous motor takes a power input. Power input is equal to, it will take a power input of 5 kilowatts. 5 kilowatts at rated voltage. At rated voltage, its synchronous reactance is given. Xs is equal to how much? 10 ohms per phase. 10 ohms per phase, RA 0. RA is equal to 0. Okay. And it's the excitation voltage. Excitation voltage means E. Dear students, excitation voltage means that is E. E can be called as excitation EMF, induced EMF, back EMF in motor. All meanings are same. That E is equal to how much? 400 volts. Okay, then question number 69, what is given? Delta how much? And question number 70, what is power factor how much? 71. IA how much? IA how much? Okay. See the solution. Line voltage. First of all, in the data given, unless otherwise mentioned, take always line voltage. Line voltage is equal to 400. Then what is the phase voltage? Phase voltage is 400 divided by root 3. 400 divided by root 3. That is equal to 230.9 volts. 230.9 volts. Similarly, E line also 400. Induced EMF also it will be line voltage 400. Therefore, what is EPH? That is also equal to 400 divided by root 3 is equal to 230.9 volts. 230.9 volts. Then Question number 69. For question number 69, power is given, na? Yes, power is equal to EV by XES sin delta. But power will be given total power. Dear students, in the data given, always total power you take, total power. So when power is given total power, that is equal to 3 into EV by XES sin delta. Total power. That is equal to 5 into 10 power 3. Total power is equal to, or else power per phase means divided power by 3. Does not matter. 3 into, this side I am substituting phase values, but 3. In equation, I will substitute always phase value. For 3 phases total power, 3 into EV, 230.9 into 230.9 divided by XES. What is XS value? XS is given 10 into sin delta. Sin delta. Therefore, delta is equal to, from this you will get, delta value is 18.21. 18.21 degrees over. That is delta. Delta. Next 70, question number 70. Power factor. Power factor to calculate, best thing is calculate current. Calculate current. Of course, he is asking current and 70, 71 I will do parallelly. Calculate current first. Angle will come, na? Yes. See, current is equal to IA is equal to V0 minus E minus delta by ZS at an angle theta. This is the equation for the current. Phasor difference. V0. V is equal to how much? Use phase values always. 230.9 at an angle 0. And delta E is equal to 230.9 at an angle minus 18.21. That is a delta. Delta always minus. Of course, magnitude we are calculated 18.21 divided by ZS. How much ZS? 10 at an angle 90 degrees. 10 at an angle 90 degrees. Then with this calculation, you will get IA is equal to 7.3 at an angle minus 9.1 degree. That is itself 5. Therefore, IA is equal to 7.3 amperes, but power factor is equal to cos phi. A cos 9.1, yes. Of course, minus 9.1 also you will get what is that value? Cos value minus plus both are same, na? Yes. So power factor is equal to 0.987. 0.987 lagging. Lagging. Why lagging? Because negative. Phi is negative, na? When phi is negative, then it is lagging. Lagging. Phi is positive, say, angle of the current. We are taking voltage 0. Current is leading means plus, I leads. I lags means minus. This angle is coming, na, that is deciding thing. Phi is minus 9.1. Therefore, it is lagging only. If it is coming plus some positive value, then power factor will be leading. Current leads with respect to current. Okay. This is the question. This type of questions commonly you can expect. Right? Yeah. Now. Similar 72, 75 questions you can do it. 72, 75 questions I have given based on the impedance also given. When impedance all that given, how to use your equation? Full equation. When RA XS is given, power is equal to V square by ZS cos theta minus EV by ZS cos of theta plus delta. Right? In the question number, in question 72, I don't want to do in question number, question 72, 75. 72, 73, 75. No? 72, 73, 75. 72, 73, 74, 75. RA also given. RA is given. ZS is given. Na? RA and XS both are given. RA is equal to how much? When RA is given, XS is given. It is given here 2000 volts, 3-phase, star connected, synchronous motor. Synchronous motor has effective resistance. RA given 0.2 ohms. XS is equal to how much? 2.2 ohms respectively. Power input is equal to 800 kilowatts. 800 kilowatts. E line is given. E line voltage is given how much? It is 2500 volts. 2500 volts. Okay. Then he is asking what is the delta current, power factor, all those things. Then what is the line current? IL is equal to how much? Delta is equal to how much? Delta you can calculate. Delta how much? IL how much? Power factor how much, etc. Dash, dash, dash. In this question, how you can solve? I will give the hint, that's all. Hint is you can do the same thing. Hint is since RA and XS both are given, therefore useful equation, useful power equation, full equation for P. What is that P? P is equal to V square by ZS. No, we have to use all the things. Power is equal to V square by ZS cos theta minus EV by ZS cos of theta plus delta. Okay. From this you will get delta and then current again, power factor again. Okay. But when you are using power by 3, you can do left side. Or right side you can multiply by 3 into 3. Whatever you want, you can do it. But power per phase, na? You divide power by 3. This side you can substitute simply phase values. Or else total power is taken, you multiply 3 right side. Okay. So I don't want to do this. What I mean to say is total. This equation is correct only in a power equation. Power equation. Do nothing to worry. You can also able to define power equation. How to remember power? How to recollect the power? You may be feeling how to recollect the power equation. P. 3 steps. In 3 steps. Okay. We know that. What is that? IA is equal to IA conjugate. IA is equal to V0 minus E minus delta by ZS at an angle theta. Okay. What is IA conjugate? Tell me now. IA conjugate is equal to V by ZS at an angle plus theta minus E by ZS at an angle theta plus delta. Correct? Yes, theta plus delta. Then what is power? You multiply V on both sides to conjugate. Conjugate V square by ZS cos theta minus EV by ZS cos of theta plus delta. Correct? Yes, IA conjugate. For IA conjugate, you multiply V, take cos components, active power. Reactive power if you want, V square by ZS sin theta minus EV by ZS sin of theta plus delta. Correct? Fingertips. This equation, nothing is there. After getting some confidence, nobody can stop you. Okay. IA conjugate, P. That's all. This is step 1. Step 1, step 2, step 3. That's all. Right? Step 1, step 2, step 3. Yeah. You can practice. I don't want to do that problem. Okay. Next one. 76, 77. Mainly I want to do that problem. Okay. That will be the last problem. And dear students, efficiency also, if some efficiency problems are there here, losses I don't want to discuss. Losses are same. Whatever you have discussed losses in the transformer, you have discussed, induction motor you have discussed, DC machine also you have discussed. Losses are same. What are the losses? Copper losses, iron losses. Okay. Mechanical losses, friction and vibration. Here also same. Efficiency is what? Power output by power input. Synchronous machines generally last part of the machines. That's the reason they won't discuss. Even you take textbooks also, not necessary to discuss. Already losses are same, na? Efficiency problems are common. Okay. Yeah. I want to do one problem. After this, I will go to the next topic. With this problem, we are going to close the problems. Anyhow, all problems are being given for you. No? In the material, dear students, in the material, I have given sufficient number of problems. Solved problems I have given. For each model, one problem. Solved problems are given. Just to do that. Okay. And do all previous gate questions.
Sir, volume 1 or volume 2, sir?
This volume, what is this? This book volume 1 only.
Sir, first we have to give preference to volume 1, sir.
Volume 1 only. Volume 2 bits bytes don't do that problems. Right? So there it is bits bytes, all those things is given just for interest of other competitive examinations. But there are so many problems are there. Don't waste unnecessary time. Because there is huge number of problems are given. First of all, students, they will self demotivate. Don't do that. When time is there for you, long run. For right now, time is not there. Na? If time is permits, okay. But now, whatever I have given this problem, that is enough. Don't do. For each model, one problem, minimum one problem, maximum two problems. Don't do extra. Because such type of problems on the concept, whatever we have discussed, known things only problems will come. That's all. It is only little practice is required. Even unnecessarily, if you do 100 problems, what is the use of it? No. You know, clear-cut concepts is there. Implementation. So, two members are doing, the steps may be the one step may be that side or this side. But finally, you came to know that what is to calculate. That comes only by practice. Right. Whatever I am using now, these questions are there in the volume 1 that you do. Right. Last question. After this, we will come to the one more topic is there. Small topic, around some 15-20 minutes, but very important one that we will complete and close. 76-77. 76-77. Yeah, this question. This one. 76-77. Already we have done one problem, this kind of problem. Gate problem. Gate 2008 examination, 2012, 2015. But this is not previous gate question. I have given this question I am doing from 2004 onwards. 2004 material also, if you see this question is there. Later on, nearly 4 times this question, similar question was appeared. The question in the sense, either excitation increases or mechanical load increases. Only two kind of questions on synchronous motor, concept based. Other questions I have done, power factor correction, all that is okay. Yeah, let us do this. A 230 volts 4-pole 50 Hz star connected synchronous motor has an impedance of 0.6 plus J3 ohms per phase. Impedance is given. Its field current is so adjusted that motor draws 10 amperes at UPF. Motor draws 10 amperes at UPF. Rated voltage source. With field current unchanged and the field excitation is kept constant, the load on the motor is increased till it draws 40 amperes from the supply. 40 amperes from the supply. Then what is the operating power factor is how much? The torque developed is what? Torque developed. Okay, torque developed. Yes. Let us do this. Yeah. You have taken na? Yeah. Question number 76 and 77. 76 and 77. Page number 245. Okay. Question is given a 230 volts and 4 pole 50 Hertz, 50 Hertz synchronous motor, 50 Hertz synchronous motor. Synchronous motor has an impedance of ZS. ZS is equal to 0.6 plus J3 ohms. J3 ohms per phase. Motor draws 10 amperes. Motor draws 10 amperes A to UPF. Okay, yes. Field current unchanged. Field current is kept constant. Field current unchanged. Field current unchanged means that is excitation is kept constant. Excitation is kept constant. Excitation kept constant. Okay, unchanged. If the load on the motor is increased, motor is increased till it draws 40 amperes. Load is increased. Load on the motor is increased till it draws 40 amperes from supply. Then question number 76. What is power factor is? Operating power factor is, and 77 torque developed is. Okay. Earlier we have done this problem per unit values. Yes. See, a 230 volts. Line voltage is 230, na? Yes, star connection. Nothing is given, you assume star connection. Three phase ante star connection you have to take. Yes. 230 volts. Therefore, what is phase voltage? 230 divided by root 3. 230 divided by root 3. 132.8 volts. 132.8 volts. Okay. And ZS is equal to 0.6 plus J3 ohms. 0.6 plus J3. That is equal to ZS. ZS is equal to 3.06 at an angle 78.69 degrees. That is itself theta, na? Theta. Impedance angle is theta. Motor draws 10 amperes at UPF. 10 amperes at UPF. Okay. Now, then you have to calculate E value. E how much? E is equal to E. E is equal to, you can calculate E is equal to how much? E is equal to square root of V cos phi minus IA RA whole square plus V sin phi minus R plus IAXS whole square. Calculate that E is equal to V. 230 into power factor 1, na? Yes, 1. Minus IARA. Current is equal to 10 amperes. IA 10 amperes, na? Yes, IA 10 amperes. RA 0.6 whole square plus V sin phi 230 into 0 plus IA. IA is equal to 10 into XES 3 square. Therefore, E you will get 130.29. 130.29 volts per phase. 130.29. 130.29. Okay. Yeah. Next. This is at what value? 10 amperes UPF. All these things are 10 amperes UPF. Now he is keeping excitation constant. Excitation is kept constant. Therefore, excitation constant means E same. E same. Since excitation is kept constant, therefore E constant. E constant, that is equal to how much? E whatever the earlier value, 130.29 is same. 130.29 volts constant. That is constant. Okay. Yes. V of course anyhow constant. But when load on the motor, is increased, when the load on the motor is increased, then delta increases, current increases, but current is given how much? Current is given 40 amperes. 40 amperes given. Then what is the power factor you have to calculate? Power factor you have to calculate. Power factor. Right? Tell me how to calculate power factor. As I told, to calculate the power factor, best thing is calculate the current. Calculate the current. But to calculate the current, delta is required, na? Yes, delta. In synchronous motor, these conceptual problems, delta is very crucial. Delta is most wanted. Whether is not asking in the question also, delta is part of the problem. Delta need to be calculated. How can you calculate delta? I told, na? Yes. IA ZS is equal to, this is IA ZS is equal to what? V0 minus E at an angle minus delta. That is equal to square root of V square plus E square minus 2VA cos delta. Very, very important relation. Okay, yes. Two phasors, A minus B, A square plus B square minus 2AB cos of the angle. So IA is equal to how much? IA is equal to 40. IA 40. ZS how much? ZS. Yeah. ZS is equal to ZS 3.06. Yes, 3.06. 3.06. That is equal to V square. V is equal to 132.8 square plus E square how much? E square 130.29 square minus 2 into V. 132.8 into V. 130.29 into cos delta. Therefore, what is the delta value? Now calculate delta. From this, delta is equal to, you will get 55.4 degrees. 55.4 degrees. 50.4. Now calculate IA. Then IA is equal to V0 minus E minus delta by ZS at an angle theta. Current. So V is equal to, V is equal to 132.8 at an angle 0 minus E 130.29 at an angle minus delta minus 55.4 degrees divided by ZS. ZS is equal to 3.06, 3.06 at an angle 78.69, 78.69. That is equal to, if you calculate, again you will get 40 amperes only. We know already current 40 amperes, but I am interested about this angle. Whenever power factor is asked, I will calculate current again, because that is the simplest method. Calculate current, take the angle of current, no? Yes. The current is equal to minus 17.4, minus 17.3 degrees, minus 17.3 degrees. That is itself phi. Therefore, power factor is equal to cos phi, cos 17.3 degrees. That is equal to how much? 0.954. Lagging. The lagging. Okay, you can also expect answer lagging. Why lagging? Earlier it is UPF, but when load increases, it will shift to this side. Delta increase. Delta increase, na? Yes. Delta has increased. Initially, it was like this. How much? This is operating at UPF, no? Yes. This is V and E. Earlier, it is operating at UPF. Current IA is equal to 10 ampere. 10 ampere. But now, when load is increased, excitation same. E same. But when load is increased, means E has increased. That E increased. Delta increase. Delta now it is 55 degrees. Now this is IAXS. IAXS. This is 55 degrees. 55.4 degrees. Earlier delta, how much it is? It is less. So therefore, now IA, where IA will come, this is going to be IA. That IA is equal to 40 amperes. Power factor is lagging. Power factor lagging. This angle itself 17.3. 17.3 degrees. Okay. Lastly, torque develop. Torque develop. Torque is equal to power developed by omega. See. The power developed. Power is equal to, question number 77 here, yes. Mechanical power developed. P mechanical is equal to power developed is equal to power input minus copper losses. Minus copper losses. Power input is equal to root 3 VL cos phi minus 3 IA square into RA. Total copper losses. Mechanical power developed, total power minus that. Root 3 into 230 into IL 40 amperes. What is the power factor? 0.954. 0.954 minus 3 into 40 square into RA. RA is equal to 0.6. So that is a mechanical power developed is equal to 12.035 kilowatts. This is mechanical power developed. Then torque developed is equal to torque developed. T is equal to what? P mechanical by omega. P mechanical by omega. P mechanical is equal to 12.035 into 10 power minus 3, 10 by 3 divided by 2 pi n by 60. 2 pi n by 60. But n is equal to, what is n value? 4 pole 50 edges. Now 4 pole 50 edges means it is 1500. 1500. This is 1500. 2 pi n by 60. What is that value? 78.34. 78.34 Newton meters. Okay. Yes. Right. This is the type of questions. Right. Okay. Now, any problems you are not coming, say, you can send it to me. I will give the solution for you. right? Or else one thing I will do, I will send the solution. I am also having soft copy of solution of these all the synchronous machine questions, solutions. I will send that. Okay, what is the PDF I have shared now? So for all the questions, I have done most of the questions in that. Parallelly, we have done topic wise. Still, if any doubts are there, I will send it that copy also, solution copy also for you. Nothing to worry. Okay, if I forget, you keep message, sir, we want that copy. I will ask them to upload in the website. I will give the in charge to that, please upload. Okay, yeah. Fine. Now last topic. Yeah. So any doubt? Some of you are raising your hand. Tell me. Before that, we will. Yeah. Hello. Hello. Who is there? Hello. Raise your hands. Fine. Now I am going to the last topic. Hello, Pallavi.
Hello, sir.
Hello. Tell me.
Sir, slide number 14F.
Slide number 14F. Huh?
14. Yes, sir.
This one.
Yes, sir. Here we are taking that lag because phi is negative.
Phi negative current.
But
V is there. V
sir,
is like this. Current lagging means this is minus only you will get.
yes, sir. But if we don't find phi, then can we? Is there any other method to say that it will be lagging?
Yes, yes. E cos delta. If E cos delta greater than V, it is lagging. Generator. Motor E cos delta greater than V, it will be leading.
Sir, means we will have to find delta first.
Delta again. Delta you have to calculate.
Sir, I am saying that if we directly substitute in that magnitude formula under root V cos pi minus IRA whole square, that formula. Sir, then we have all the values, only we don't know that minus plus what will come in front of IA axis.
But
So,
you
sir,
have to expect that at that time you have to expect, is it lagging or leading? That you cannot say.
Sir, we cannot say like that?
See, what your doubt is exactly you are asking here. E is equal to V cos phi minus IRA whole square V sin phi. Sometimes you can able to predict. See, in this problem, in this question is there, na? Definitely I can expect why earlier it is operating at what power factor, ma? UPF, no?
Yes, sir.
UPF. When UPF means load increases, you apply your concept. It is UPF. When it is UPF, when load increases, what is going to be happen? Synchronous motor, E shift, IA will shift. IA will come lagging side. When IA lagging side means you came to know it is lagging power factor. Already it is UPF. It will go to lagging. There you can substitute. Lagging means minus value.
Yes, sir.
You can get it.
Okay.
But I don't know exactly, for example, you can also expect, nothing is wrong. If it is leading side is there, say, how much angle? Lagging side is there, say, you can expect. Lagging, which side it is going? Power factor is, you can expect from the phasor diagram. It is shifting lagging side or leading side. Or
okay, sir.
Okay.
Thank you, sir.
So,
right. Hello.
So in this last problem only, you took one value as we have to took phase voltage, but you took line voltage there by calculating E. Last problem 76, 77.
Okay.
While calculating E.
This one?
No, sir. Last.
Problem number?
Yes, sir. Here only, sir. Here. 76, 77.
76, 77. Okay.
Yes,
Tell me.
You took 230, sir. While calculating E.
Very good.
We have to take 130.
Yes. You are correct.
If we took this value, it gets some answer 2 to 6.
You are correct. Yes. That's what online. If offline class is there, students, front bench students, he will identify. Sir, we have taken, immediately he will inform. But here also you may be informing, but I can't. Fine. Okay. Anyhow, good. 132.8. This is your correct. Then only you will get answer. I have kept same.
Yes, sir. Answer is
Yeah,
correct,
yeah.
sir. Only this
I am
value.
having my own solution. But
Yes,
okay. Only single side, na? This is single side. That is
yes.
I cannot identify my mistakes. Okay, right. Fine. Now coming to the, yeah, I will discuss one important topic. It is a matter of course, it won't take much time. See. Yeah. The topic what I am going to discuss is yes. Heading is, it is already known things only, it won't take much time. The synchronous machine on bus bar, synchronous machine on bus bar or alternator on bus bar for various disturbances. Synchronous generator on bus bar for various disturbances. Bus bar for various disturbances. Synchronous machine on bus bar for various disturbances. Good objective questions on this. Of course, anyhow, we have completed all these concepts also, only finalization. With that, we are going to close. Okay. Prime mover. The prime mover. Okay. Yes. Yeah. Taken. In this, what we are going to do is listen. Right now the machine is acting as alternator. No, right now the machine is acting as alternator. When we are giving mechanical power, to this P mechanical we have given. It is delivering the P electrical. It is delivering P electrical. Say operating at rated condition. The machine is operating at rated condition, right? Or it may be any no load condition. We don't know. All cases, different cases we are going to consider. See, right now the machine is operating as an alternator, synchronous generator connected on the bus bar. For various disturbances, what is going to be happen? Various disturbances means, see, right now acting as alternator. Listen to me. Acting as alternator, when excitation fails, how this machine behaves. Field circuit is open or short circuited, how it behaves. Earlier alternator, field excitation fails, how it behaves. If prime mover fails, how it behaves. If both fails, how it is behaves. Salient pole machine, what is the behavior? Cylindrical machine, what is the behavior? Okay. No load condition, what is the behavior? Full load condition, what is the behavior? Which direction it will rotate? What is its power factor? All these things I am going to tabulate, right? Yes. So let us see in the next page. I will write all the conclusions in the next page. See, all combinations. The combinations are like this. See, this is excitation. This is prime mover first. Prime mover. Okay. Prime mover. And here excitation. See, this is a prime mover. And this is excitation on. Excitation on means excitation available. And this is excitation off. Or that is excitation fail. Excitation fails. Excitation fails means the field may be open circuited. Or short circuited. Meanings are same. It may be open circuited or short circuited, same. For this combination, we are going to see. Yes. Yeah. Prime mover, excitation on. But excitation is available. When excitation fails, what is going to be happen? See, first one, prime mover is coupled, excitation is available. I'm going to last slide. Prime mover is there, excitation, both are there. How the machine behaves, tell me. How the machine behaves? Machine behaves as alternator. When prime mover is there, excitation is there. It acts as alternator. So the combination is prime mover is coupled. The prime mover is coupled. The prime mover is available. Prime mover is coupled. That is, prime mover is available. Prime mover is given when excitation on. For this combination, dear student, for this combination, prime mover is there, excitation on. For this combination, how the machine behaves? The machine behaves as synchronous generator. The machine behaves as synchronous generator. Or it behaves as alternator. When prime excitation is there, prime mover is there, alternately it behaves as. And when prime mover is coupled up, but when excitation fails, what will happen? Prime mover is there, excitation fails. For this combination, prime mover, excitation off. Prime mover is there, but excitation fails. For this combination, excitation fails. When excitation fails, can you tell me, will it act as a synchronous generator? No, it will not act as synchronous generator, but it will act as induction generator. No excitation, singly excited machine, induction generator. It will act as induction generator. For that combination, it is induction generator. Induction generator. Induction generator, both salient pole machine and cylindrical also, both salient pole machine and cylindrical machine, both salient pole and cylindrical rotor machine. Cylindrical rotor machine. Cylindrical rotor machines earlier operating at full load condition. Earlier operating at full load condition. Initially operating at full load condition. Full load condition. Okay. It will rotate at what speed? Rotate at more than synchronous speed. Induction generator rotate at more than synchronous speed. More than synchronous speed. More than synchronous speed. It is acting as an induction generator. More than synchronous speed. If it is light load condition, say salient pole machine, it will also behave as a reluctance generator. Reluctance generator. When reluctance generator, initially if it is under light load condition. If it is a cylindrical rotor synchronous machine, salient pole, not cylindrical. If it is a salient pole machine, earlier operating under light load condition, earlier operating at light load condition, light load conditions, light load or no load condition, or no load conditions, no load condition. But reluctance generated at what speed? It will rotate. It will rotate at synchronous speed. Rotate at synchronous speed. Will rotate at synchronous speed. Fine? Yes, rotate at synchronous speed. Reluctance generator, it is unexcited synchronous generator, no? Unexcited. Light load condition. Light load condition. Important thing here, how it is rotating at more than synchronous speed. When excitation is there, what happened? When excitation fails, why it is rotating at more than synchronous speed? Light load condition, why reluctance generator? I just want to explain. See, coming back to our generator, whenever omega is equal to what? Omega is equal to speed, prime mover torque minus electromagnetic torque divided by B. Okay, yes. But what is mechanical torque? TPM is equal to P mechanical by omega. And TEM is equal to P electrical by omega. P electrical by omega. Now, when excitation fails, say, earlier when excitation is available, the machine is, when excitation is available, there are two torques. Na? Prime mover torque is in this direction and rotating in this direction. Electromagnetic torque is in opposite direction. When we are given mechanical power input, rated electrical power also getting, na? Yes. So electromagnetic torque is in opposite direction. Two torques are balanced. Machine is running at synchronous speed. But when excitation fails, When excitation fails, TPM is there, TM is there, rotating at synchronous speed. But when excitation fails, what is electromagnetic power? Zero. This electromagnetic power becomes zero. Electromagnetic torque zero. When opposition, braking action is reduced, then given prime mover torque will rotate at more than synchronous speed. Simple to say, excitation is zero. Say electromagnetic torque opposition, braking action fails. When there is no electromagnetic torque opposition, but prime mover torque is rated value is there, it will drive the machine at more than synchronous speed. So, see, when machine is, let me write this conclusions. When machine is acting as when excitation is available, P mechanical is rated, P mechanical and P electrical rated. Therefore, TPM and TEM rated. Therefore, machine rotated synchronous speed. Machine rotated synchronous speed. But when excitation fails, what happened? TEM is zero. Nearly zero, reduced. Strictly speaking, it is reduced. Very less value. Induction generator principle, very less. TEM is reduced. Is very less. Or nearly zero, say. Assume nearly zero, very less. TEM decrease. Or nearly zero, say. Then what is excitation fails, TEM less. Then what is omega? Omega is equal to TPM minus TEM divided by B. So this part is almost zero, reduced or near to zero, say. Then what will happen? Speed will increase. So braking action, electromagnetic torque opposition, TEM opposition is decreased, is reduced. Therefore, given TPM will drive the machine. Given TPM will drive the machine at more than synchronous speed. More than synchronous speed. Therefore, machine acts as induction generator. At that time, machine acts as induction generator. Okay, will act as induction generator. Right. But reluctance generator means if the machine is light load condition only, reluctance generator. Full load condition, it salient also it act as induction generator. Light load condition, why? Because TPM is itself less. Dear students, listen. Light load condition, first of all, prime mover torque very less. When prime mover torque is less means reluctance torque also less. Reluctance torque 20%. Prime mover torque also 20%. It will rotate at synchronous speed. If salient pole machine, light load, that's the reason I have given light load condition means prime mover torque is very less. When excitation fails, TEM zero, but reluctance torque is there, na? That reluctance torque will restrict the speed to synchronous speed. Let me give that point also here. See, light load condition, when excitation, when the machine is operating at light load condition, see, TPM is small. Say TPM is nearly 20% of TPM rated. So at that time, Okay, don't worry. We will close. Okay. See, light load condition. Machine is light load condition means P mechanical is very less. P mechanical is small. Is small. And this is TPM. TPM. It is rotating omega. Okay. But if it is a salient pole machine, what are the torques are available? EEM will be there and T reluctance also there. T reluctance also will be there. T reluctance. Both are there. Now omega is equal to TPM minus TEM plus T reluctance. Both are there. Divided by B. That is the speed. But when excitation fails, what happened? Excitation fails, TEM nearly zero, but T reluctance still exists. T reluctance still exists. T reluctance still exists. Exist in opposite direction. In opposite direction. In opposite direction. Okay. Yes. Since TPM also small, TPM is nearly some 20%. T reluctance also nearly 20%. Therefore, the machine will rotate. Therefore, the machine will rotate at synchronous speed. At synchronous speed. Synchronous speed. And machine behaves as, machine act as reluctance generator. Reluctance generator. Okay, reluctance generator. Right? Act as a reluctance generator. Lastly, TM 0, but TPM also small is given, na? Then reluctance torque opposition will be there. That is sufficient. Next combination, let us see. Next combination, when prime mover is filled. So far excitation is available. Open what will happen. Now prime mover is decoupled. Prime mover is decoupled. Decoupled, or that is prime mover failed. Prime mover is failed. Prime mover is failed, say. When prime mover failed, excitation is available. How the machine behaves? Prime mover is decoupled. Excitation is available. Prime mover failed. Prime mover has failed. Excitation is available. Tell me how it behaves. Is it behaves as generator or motor? No question of generator, because no mechanical power input. Prime mover failed, disconnected. Now it acts as a synchronous motor. Synchronous motor. Synchronous motor. So therefore, excitation is available. Synchronous motor. Synchronous motor. Rotate in which direction? That is the question. Synchronous motor rotate in same direction, opposite direction. Induction motor, synchronous motor rotate in same direction. Rotate in same direction as before. Same direction as before. Rotate in same direction as before. Okay. In all cases, rotation is not going to be changed. Right. Next, lastly, when prime mover is decoupled and excitation also failed. Prime mover is decoupled, excitation fails. Both are failed. What is this combination? This combination. Prime mover is failed, excitation also failed. Now it acts as a motor only, but it is not a synchronous motor. How it behaves as induction motor. Cylindrical అయితే induction motor. Salient pole, reluctance motor. Fine? Yeah. So that is, it will behave as induction motor, if it is a cylindrical rotor synchronous machine. If it is cylindrical rotor machine, but rotate at what speed? Rotate at less than synchronous speed. Rotate at less than synchronous speed. Less than synchronous speed. And reluctance generator, reluctance motor. Reluctance motor. Reluctance motor, if it is a cylindrical machine. If it is a salient pole machine. If it is a salient pole machine. It is light load condition only, because when prime mover fails, no load is connected earlier. Earlier prime mover was there. Prime mover disconnected means no load. If it is a salient pole machine, but rotate at what speed? Rotate at synchronous speed. It will rotate at synchronous speed. Rotate at synchronous speed. Okay. These are the combinations. Combination. All the rotations are same. Rotation in same. Rotated synchronous speed. This is reluctance machine, unexcited machine. Reluctance motor also not self-starting, dear students. Reluctance motor is not self-starting. Synchronous, it is also synchronous motor, unexcited. Now I will ask one point for you. What is the power factor of a induction generator power factor? Leading. Because unexcited. For synchronous generator, excitation is removed means no excitation, leading power factor. Induction generator operated leading power factor. Leading power factor. Induction generator power factor is leading. Okay, induction. This will operate at leading power factor. Induction reluctance generator operated also leading power factor. Leading power factor. It is also leading power factor. Induction motor lagging power factor. Lagging power factor. Induction motor lagging. Reluctance motor also lagging power factor. Right? Yeah. So for these combinations, remember these things. Rotation same. In all cases, all they will rotation same. Unless otherwise you are not changing phase sequence, no? Rotations are same. Fine? Yes. So with this we are completed all our syllabus. Fine? So prepare well. Any doubts are there, you are welcome. Right? Yeah. So you can ask later also. Don't think this topic is completed and sir is nowhere with us. Not like that. We are working for you people. Students, we are working for you people. Okay? You are getting good rank is important for us, no? Yes. Okay. Yeah. So with this, our class is completed. And those who are having doubts, you can ask. And those who are not having any doubts, please leave. You can leave the class, or else you can stay You can also listen the doubts of your friends. Okay. So with this, we are completed our topic. Fine. Yes. Yeah, I will come to your doubts. I'm unmuting. You can ask.
Hello, sir.
Hello, sir.
Hello.
Hello. Sir, when that excitation is off, that is acting as a generator.
Generator.
Okay.
Generator,
Sir,
induction generator. When it's induction generator.
Induction generator. Okay. At that point, just when there is excitation is just up, that is rotating at synchronous speed.
When excitation is available, it acts as a generator, rotating at synchronous speed.
And when the prime mover end is removed,
Prime mover,
when prime mover is removed, then at that point it will be means that previous class we said that it is the damper bar will be come into picture. But due to, can I say that due to this same speed, no jerk will be appear.
that is okay. Already it is running condition. Then it will continue, but it cannot rotate at synchronous speed. Prime mover is there or disconnected?
That prime mover is connected.
You are saying which condition? Tell me.
Means the second condition when the prime mover is connected actually.
Prime mover is connected, then excitation phase.
Means nearly synchronous speed. It is rotating nearly synchronous. That you said that TEM is nearly 0.
No, you are talking about which case? Induction generator?
Case 2, sir. Case 2.
Case 2, okay. Case 2 means in this slide, tell me what is.
Means I have a general doubt that what happened in the machine actually exactly. Means when what happened in the machine exactly when that excitation is off and a prime mover is on. Prime mover is connected.
Yes. The damper winding will be there. Based on the damper winding, it works as induction generator. If it is
means for a very
very less only. See, this machine, synchronous machine, has been designed to operate with excitation. This is theoretical discussion only. Theoretical discussion. But if it is in the plant, if excitation fails, right, automatically the governor system will comes into picture, control system will comes into picture. It is disconnect the machine. Machine has to be disconnected at the end. But theoretically, how it is acting, that is the induction generator. Theoretically.
okay. Yes.
Theoretically, but practically we cannot operate. The synchronous machine design is different. We cannot operate this as the synchronous motor. Their air gap is more. Without excitation, the operate poor power factor will absorb large current, large reactive power. It will absorb induction generator. Poor power factor and current is more. Abnormal operation theoretically.
And at a leading power factor, it is operated.
Yes. Because under excitation, now you can draw the phasor diagram of induction generator. You have drawn for synchronous generator, under excited, it will also like that. Okay.
Thank you, sir. Everything.
Hello.
Hello, good evening, sir.
Good evening. Tell me.
Sir, you have said that when prime mover is available and the excitation is not available and lightly loaded condition, it will act as a reactance motor, na, sir?
Where prime mover is coupled or there?
Coupled, and excitation is unavailable and lightly loaded condition, it will act as a reluctance motor.
No, not motor, not motor, generator. Generator only, because as long as prime mover is available, you are giving some power, na? You are rotating.
Right,
as long as prime mover is available, it is generator only.
Yes, sir, generator.
Generator.
But sir, you have said that it will operate at synchronous speed, but from equation, it is not looking like that. If prime mover torque is same, sir.
I am giving prime mover torque also very less, sir.
Okay, it will also reduce, sir.
No. Initially, the machine is operating at light load. Light load means synchronous machine connect on the bus bar. How can you operate 50% of the load? You have to give 50% of prime mover.
Right. Right.
If you have given 20% of prime mover, then
Okay.
only if prime mover excitation fails, reluctant torque will be there. Na? That reluctant torque is sufficient to restrict the speed. Otherwise, if you have given 100% torque, when excitation is fails, 80% of electromagnetic torque 0, then 20% it cannot stop. Then it will rotate it induction generator. That's what I told. Light load condition only. Full load condition it cannot.
Means in
Prime
running
mover torque.
condition,
How much prime mover torque you have given? That is a load. 100% prime mover torque you give, that is full load.
yeah, right. Sir. Means in running conditions, reluctance torque will not act in its full extent, sir.
Reluctance torque?
Will not be having its full impact on the rotation, sir.
It will be there. But reluctance torque, how much it is? Independent of excitation. No? Reluctance torque 15 to 20% only exists.
Yes, sir, right.
Prime mover torque also I have given 15 to 20%. Then it is sufficient to restrict the speed. Omega TPM minus T reluctance, it may be sufficient.
Okay, sir. Understood.
Yeah. Yes.
Hello, sir.
Hello.
Good evening, sir.
Good evening.
Sir, in last problem 76, 77 is there, no, sir?
Last problem.
Question number 76, 77.
Uh,
Sir, in that for the UPF power factor, E cos delta equal to V. From that we can find the delta also, no, sir?
when these numericals are given, yeah.
Yes, sir.
E
There
cos
is-
delta.
From that delta we can find, no, sir. Why we can't doing that much, sir?
That is okay. No. He is asking, earlier it is operating at UPF, okay. But next when load increases, how can it is UPF? It will go to lagging side. Na? This is V. Okay. This is operating at UPF right now. E, it is operating at UPF. But when load increases, current will shift to this side. Na?
Yes, sir.
It is not, it will go lagging. At that time, you cannot utilize. He is not asking to calculate the current at UPF. Already it is operating at UPF, but when load increases, it will go to lagging power factor. There you can
Yes, sir.
apply. Yes.
I got you. Thank you so much.
Okay. Hello? Avinash.
Hello.
Hello. Tell me.
Hello.
Hello.
Hello, sir.
Sir,
Hello. Tell me.
Sir, in the formula of omega TPM minus TIB, is that correct?
Oh, your voice is not clear. Your voice is totally fully breaking.
Hello, sir.
Yeah, tell me.
In the omega formula, TPM minus TEM by B. So what is the B actually?
This equation I have given very beginning, beginning classes. Omega is equal to prime mover torque minus electromagnetic torque by B. B is friction coefficient. Magnetic drag, I was explaining.
Friction coefficient. Okay.
Magnetic drag, we are explained that omega is equal to TPM minus TPM. Very beginning.
Sir, one more doubt in starting methods of synchronous motors.
Tell me.
Sir, when we are using pony motors for starting it.
Yes.
Hello, sir.
The pony.
Sir, then you are told that we keep the number of poles less than
Yes.
less than the synchronous motor.
Yes. 2 poles.
So, sir, when
not when it is one method.
Hello, sir.
Auxiliary motor starting is there, na?
Sir,
there we can use. Okay? Pony motor
yes,
function is only pony motor is just for design only to starting purpose of synchronous motor. Because its speed is 2 poles less than means rotor speed becomes equal to the synchronous speed of synchronous motor. To make these speeds very closer to that, its actual pony motor speed has to be bring to very closer to the synchronous speed. That's the reason 2 poles less than means its rotor speed is equal to synchronous speed of synchronous motor.
okay, sir. Sir, but in a synchro, we have used the 2 pole synchronous motor. Then what amount of pole?
That is not valid. That question is hypothetical question. Poles will be minimum. Actually, synchronous motors low speed, na? Poles will be 20, 30, practically more poles. 2 poles
Okay,
means a compulsory 2 poles.
All right, sir.
Minimum 2 poles will be there. Yes.
Sir, in that case, then the pony motors we will not use for that.
It cannot be used. It cannot be used.
Okay. Thank you.
Yes. Yeah, I hope it is clear. Now I am closing my session. Hello, anyone is there?
Hello, sir.
Bhimalesh, tell me.
Sir,
Yeah.
last means that I said previously that when the excitation is up, when the excitation is up, means it is connected to bus bar, and at that time we know that the TEM only comes to picture when there is load is connected.
Very TEM not exactly 0. Induction principle also small electromagnetic torque is developed, but that is less when excitation was present.
From the beginning we have studied that TEM will be come into picture when IF flow, means that armature current flow.
Yes.
And you said that it is behaving as a generator.
Induction generator. Yeah.
But generator, but where that TEM, that TEM is not there. When current is we are not exciting, means no EMF is generated in the armature conductor, so that no TEM will be come into picture.
No.
How that generator principle works?
See. There, what will happen? Just like induction generator. Induction generator, you are not giving anything. Na? There, which flux is there? Then damper winding, rotor speed increases, damper winding will be there. Na?
Yes.
RMF is produced. Induced EMF will be because of induced EMF. Phi R is equal to what? Phi R is equal to phi M plus or minus phi A. Okay?
Yes.
When, for example, see, due to this phi M, your induced EMF is some 400 volts. Okay?
Yes.
When load connected, phi A will comes into picture. If it is lagging power factor, say, net EMF will be reduced. Right?
Yes.
Due to phi A also, induced EMF will be there.
Okay.
When DC excitation is not there, that will cuts by the armature flux. Armature conductors, armature poles are there, they are rotating.
Okay. IM is 0. Yes, excitation is.
Excitation 0, but these poles are rotating. Na? Stator poles are rotating. Relative speed between stator poles and stator conductors. How much it is? NS. They will cut. And that is induced EMF not only now, earlier also was there. Earlier we are discussing resultant. Total flux we are discussing. Phi M and phi A, anyhow, both are stationary, no?
Sir, how this is NS? Because rotor is just, it is just supply of, so it is already conducting. It is conducting mode.
No. Repeat what you are.
Means that you said that the relative speed is NS.
Relative speed between what?
That is
armature conductors and the armature poles. What is the relative speed?
Okay. That is NS because of supply.
No, that's what only I'm telling.
Okay.
This your motor is there. Right? So this armature poles, they will form. North pole, south poles, they are forming. And this is stator pole, south pole, north pole. So net flux will be, you forget about for some time, this is rotor flux. And stator flux is there, stator flux will crosses the air gap. And stator flux also rotating, that also cut the conductors, na? EMF is induced.
Yes.
EMF is induced. That is only because of armature flux, say. Right? And when main field flux is there, what is the net flux? Net flux is equal to phi R, phi M plus phi A. If this flux is adding, net flux is more, EMF is increased. When this flux is not there, only flux is phi A.
Okay.
ER I told, na? ER.
Yeah.
If it is leading power factor, that ER increases. ER will be more than.
We are saying it generator. Why not motor? Because that is yes, that E is generating due to supply.
Why motor? Because see, as long as I have given prime mover, mechanical power I am giving na. What is the use of that according to energy conservation?
That will be the energy will be definitely somewhere.
Definitely delivered.
Okay.
E vector will leads.
Okay.
That we cannot stop. Blindly we can say as long as prime mover is there, that as generator. Prime mover failed means motor. You can see the table that also you can find.
And it may be that EMF is generated in the armature conductor also. It will be.
Yes, yes, yes.
Yes, because of that power conservation.
And that to be when excitation fails, what happened? Damper winding also will come into picture. Induction principle takes place. EMF is induced in the damper winding also. Poles are induced in the damper winding also. Now it like that damper winding will come into picture when rotor speed increases. Na?
Okay. Thank you, sir.
Okay. Right.
Thank
All the
you
best.
for everything. Okay.
Right.
Okay. Thank you.
Fine. I'm closing the session. Right.